Good morning, all. Before we start with anything, let me welcome all of you on behalf of SunBeam. And I'm really happy that you all have joined and showing interest in learning Python. You already have seen how important Python is in today's world. I mean, not only in ML, not only in machine learning, it is used in many different domains, many different technologies. For example, if you go to image processing, there is a very popular library called as an OpenCV, which is developed in Python. Actually, it is developed in C++, but more than C++, it's popular in Python. If you go to the testing domain, you might have heard about there are two types of testings, manual testing and automation testing. So in automation testing or test automation, Python is considered to be the language. So testers generally use them simply because Python is very simple language. And believe me, it's that simple. You can learn it in a couple of weeks. And not only you can learn it, you can master it in a couple of weeks. Now, what you need for mastering Python is what we have covered in this particular course. So, as I was saying, Python is not only important for machine learning. Those who are willing to go in data science, those who are willing to be machine learning developers or AI developers, for them, Python is going to be bread and butter, no doubt in that. But not only for machine learning, this is also important for all of them who want to start developing or start making their career or pursuing their career in computer domains because of the popularity. So this is the reason why we have started with this course, and that is the only reason I believe all of you have joined this course. Now, before we start with the actual content, I think it's better for me to give you an introduction of what exactly that we are going to see, how exactly that is already laid out, and then we'll start with the subject. Okay. So this is something that we are planning to cover. There are many topics. I can see that here, but let's say one by one and see what exactly the topic is all about, what that we are going to see in that topic, and how it's going to help you in order to learn and master the Python. So end of this course, my aim here is you should not only feel confident, but you should master Python so that you can start using Python in different domains. So this is what we are kind of aiming towards. This is what our goal here is. So starting today, we will be talking about how the Python is evolved, or what exactly the Python language is, or precisely what language is. So we'll start with introduction to the Python. Here we'll try understanding what exactly the Python language is all about. Like what is a language, first of all. So we'll start from here. We'll start with what is a language. We'll start with the compiler or compiled versus interpreted language, when you are going to use one, or what's an advantage of it, what exactly you get when you are saying the interpreted language, and what exactly Python is, whether it's a Python compiled language or whether the Python is an interpreted language, and why it is important for you to understand that. Then we'll understand something called as a PVM and a C Python. So in today's session, you are going to understand what exactly the Python virtual machine is, and why is it important to know Python virtual machine, and how your Python, even simple or very complex program, runs inside your machine. Right? Who runs your Python code? The Python code is run by using something called as Python virtual machine. You might have heard about Java also. Java is also a very popular language. Java also follows the same philosophy. So whatever that you are going to learn in Python, 90% of this you can find in Java as well. Like Python as a PVM, Java as a JVM, so on and so forth. Both of them are following the same philosophers. And that's why this is what I generally know. Like I would generally say, when you buy one, you get always one free. So this is something like you are learning Python, you by default learn 50% of Java. I don't say 90%, 50% of Java, because remaining 50% is all about syntax. So in this particular case, you will start understanding the languages, fundamentals of languages. Then we'll start talking about the Python today itself. That's introduction to the Python. Now, once you understand what exactly the Python language is, or what exactly it is coming from, we dive into the next part of environment configuration, meaning we will install Python on our machine. Now, how do we install Python on our machine? Now, today we'll be starting with a simple environment. We'll be using, there are multiple options available. We can go for something called as a Conda, which is generally preferred in the ML world. I mean, it's something that you can decide, or we can directly go for installing it using the Python.org, which is like downloading it, or you can use it something like a package manager. I'll show you the different options available. So we can install it by using package manager. Not today, but later in future or in upcoming classes, we also will talk about virtual environment. This is known as VENV, virtual environment. Now, what do you mean by that? I'll explain it later. But today we'll be, installing it physically. That's called the physical environment. But later we can also create a virtual environment, which is important when you are developing multiple applications in Python, which require different versions of Pythons or different versions or different set of libraries or packages to run that application. So instead of mixing together and creating a chaos, you can directly go for creating a virtual environment. Again, more on that later. This is just a quick introduction to you. So either you can go for Conda, you can go for package manager, like we'll see an example later. And later in future, we'll convert our physical into virtual environment. And this is an important concept for both ML developers and some image processing libraries or image processing applications or something like database connectivity and a bunch of other applications out there. Now, once the environment is configured, we directly will start writing the Python code. Now, when we start writing any language, irrespective of the language, every language starts with a very simple variable concept. And if you want to go for declaring a variable, we have to understand something called as data types. Now, precisely in Python, there are 5 data types, something like, string, boolean, numeric, something called as a sequence, dictionary, and set. So basically, when we talk about data types, there are 5 categories. There are different data types, but there are 5 categories there. So we'll understand those categories in this particular topic. Like, what do you mean by starting with a numeric data type? In numeric, there are something like integer, float, and something like a complex. Then there is a boolean. This is the data type available here. Very simple. Then there is a sequence, string, array in the sense list, and tuple. All of them are sequences. Then there is a set, and then there is a boolean. Boolean, I think I already mentioned it. Something like sequence, set, and a map. That's it. So there are 5 categories here. And when I say it's not called as a map, it's called as a dictionary. I mean, map is right, but the right word here is called as a dictionary. So basically, when we are talking about data types, there are 5 categories, and in that category, you can find different data types there. What is a data type? Later tomorrow, we'll talk about it. Later next session, we'll talk about what data types are and what exactly do you mean by that. But just to give you a glimpse of it, data type means type of data. In a sense, when you are declaring a variable is a place in the memory where you want to store your value. What kind of value that you want to store in that memory, it is denoted, indicated by using this data type. So when you are kind of reading that value, machine will tell you, okay, this is a string or this is a numeric like integer or float, so on and so forth. So this is going to be bread and butter for every Python developer. Without knowing this, you cannot declare your variables. Of course, good thing here is in Python, you can declare the variables dynamically. In a sense, you really do not need to know what data type of variable is. But knowing this will give an advantage that you can decide what kind of operations that you can perform on that value or on that variable. And that's the reason why it is important for you to know it. Now, once you start declaring the variables, knowing the data types, we immediately will go and start performing some operations on them, by using different type of operators. Now, there are a bunch of operators out there and they are divided into different categories. Like, for example, there is arithmetic operators. Like, for example, plus, minus, division. Maybe division has got 2 versions in Python, like floor division and true division. Then there is a raise to or power operator, and there are a bunch of others like modular and all of that stuff. That's arithmetic. Then we'll go for comparison operator. Now, when I say comparison, it's like less than, greater than, less than equals to, greater than equals to, double equals to, not equals to, so on and so forth. Then we'll talk about something like the bitwise operator, bitwise operator, performing operations bit by bit, not on the byte level, not on the value level, but bit level. That's what's the bitwise operator, bitwise and bitwise or. And then there is logical operator set. So logical and logical or. Whenever you are writing program, irrespective of logic, we have to perform some operations. And to perform operations, we need something like these operators. I mean, without operators, you can't do anything. And that's the reason, again, irrespective of any language, I'm not only talking about Python's perspective here, but irrespective of any language, every language will have the data types, every language will have the operators. Without them, you cannot write even a simple or hello world type of application there. So in this particular case, the operators will tell us what kind of operations we can perform on those variables, arithmetic, comparison, bitwise, and logical. Now, once we understand something like operators, once we understand something like, by the way, when I say operators, you have to write something called as statements in order to perform those operations. And statement is nothing but the code that you are going to write, which is going to get executed. Like, for example, if I say num is going to be equals to 200, this is called as an assignment statement. Now, there are a bunch of type of statements available there, like control statements or something like, the comments or normal statements, so assignment statements, so on and so forth. A statement is nothing but the one that gets executed by Python. So what executes is nothing but a statement. Now, in that case, when you are writing the statements, there are multiple types of statements, and this is one of the important type of statements called as control flow. In a sense, if I'm writing some code and if I need to understand or if I need to add some kind of logic, some kind of condition, this is where the condition like if else comes into picture. If, for example, then there is a if else, and then there is if elif else. If, elif, it is known as, and else. Then there is a break. These are all control flow statements. They will they give you an option to flow your control conditionally. So this is called as a control flow operations or control flow statements. These statements will help you to write your logic by adding some conditions, and that condition checking is very important in writing complex logics. So that will tell you like how do I flow, how do I give my application a logic and tell that logic like go from here to here when there is a condition X true, go from here to there when condition Y is true, so on and so forth. That is known as control flow. This is very fundamental. Till this point, I think you can cover all the fundamental aspects of Python. Now, once you understand fundamentals like something, statements, variables, the data types, the control flow statements, then we enter one of the most important topics in Python called as a function. And why am I saying this is one of the most important? Because Python is something called as functional programming language. Now, let me tell you what exactly it is. More on that we'll discuss later. But in any language, when function is considered as a first-class citizen, meaning generally when you go for C or C++ or any other languages, for example, Java, for that case, you declare variables. You say something like number equals to 20 or integer number is going to be equals to 20. In Python, the variable can be of type functions as well. In a sense, a function can be declared as a variable, and that variable can point to different functions dynamically. Amazing, isn't it? So in this particular language, functions are considered to be the de facto standards. And that is the reason why one of the important topics in Python is functions. There are many, many things which are evolving around this function. I can say like machine learning's half of the part, depends upon the functions, rather most of the parts. So that is a function. It's very important to know that. Now in Python, there are three types of functions you can write. Precisely, you can write only two, but we can convert that into three. But right now, I can say something like, let's go for named functions. Means the one that you can write with function. Within the named function, there is another one, something called as a nested or local, or you can say local. I'll just say nested function. Means a function within a function. Actually speaking, this is the type of function. This is the scope of a function. And there's another one, something called as unnamed anonymous, or in Python, that is known as a lambda function. So in Python, there are three ways. Actually speaking, there are two categories, named function and lambda function. Lambda functions are also known as anonymous or unnamed functions. Those functions which do not carry any name, those are called as anonymous or unnamed functions. And in Python, such anonymous or unnamed functions can be written by using a keyword called as a lambda. And that's another important point, because the lambda functions are used later in functional programming language a lot. So there are two ways, or there are two categories. One is named, another one is lambda. And these two functions can be nested, means one inside another. So that's called as a nested function. And again, this is the kind of, you can say, the reason why there is an advanced topic. I think I'll write it here itself. There are and there are major advanced topics later that we will see. But in this particular case, this part, unnamed function, will give us something called as closure. I'll write here, and this is another very important feature because closure later will be converted into decorator. And using decorator only, there are few libraries like Flask or Fastify. You can write the entire web services. More on that later. But right now you can say this is nested function which will turn inside something called the closure. And closure is a very important topic for certain libraries like Flask. Without closure, without decorator, Flask cannot be executed. So the understanding function is going to be very crucial for you. We are going to spend at least 2 sessions talking about only functions. It's very huge topic, very big topic, I can say. Anyways, so this is the functions part. And when I say functions part, functions will lead to something called the functional programming as well. Now, what do you mean by functional programming? As I was saying, there are languages where functions are considered to be the first-class citizens, meaning you can declare variables of type functions. Again, that's surprising, but it is what it is. So in such languages, you can declare variables of type functions. Like you can pass one parameter to a function, you can pass function to a function. I mean, function is a parameter to another function. Amazing. You can pass one function as a parameter to another function. That's called the functional programming. And the closure which I mentioned here, that means one function will be returned as a return value of another function. Again, this is called as a functional programming. And there are many functions which will follow this style of programming, this philosophy of programming. For example, which is very popular and very important, something called as a map. Then there is something called as a filter. And then there is something called as a reduce. And there is something, there are many others, but there is something called as list comprehension. I'll simply say comprehension. Comprehension. There are 2 types of actually there are 3 types of comprehensions: list comprehension, tuple comprehension, and dictionary comprehensions. More on that later. So this will something called as a functional programming language becomes a de facto standard for data handling. Without this, I mean, you can, but without this, handling data becomes very difficult. And that's the reason functional programming is going to be very important for you, which is advanced topic of function. But why I cannot, I mean, why I did not put the functional programming right next to the functions? Because when you go for functional programming, there is a dependency, and dependency is on collections. Now, what do you mean by collection? Collection means whenever you are declaring a variable, you generally will store only one value inside it. But when you declare a variable of type collection, you can store multiple values together in one single variable. Now, how is it possible here in Python then? It is possible in Python by using one of the 4 ways, one which is the simplest collection, which is called as a list. Then there is something called as a tuple. Then there is something called as a set, and then there is something called as a dictionary. So this is a kind of, you can say, the collections topic, which is going to cover list, tuple, set, and dictionary. And again, not many times, it's almost all the times whenever you are developing applications real world, like for example, you are developing a image processing application or testing application, like testing script that you are developing, or you are developing something like web services or ML, for example. In that case, you will need one or more of this topic. Now, when it comes to the collection, Python also has got collection, you can call this as a package. Collections package. I'll just write a collections package here because there are many other options available in the collections, or there are many other utilities available in the collections package. Again, going to be important for us to understand from data handling's perspective, So there we will need all these collections. So again, if you look at the functions, there are many important topics that we will learn. After functions, we will directly jump to the collections so we can understand what exactly the collections are. And using collection, we will learn functional programming language by taking care of or by taking those map, filter, reduce, comprehension type into consideration. Again, going to be very important part here. Now, this is foundation number 2. This, I mean, starting from this to this is foundation one. Starting from this to this becomes the second foundation or second level of foundation. Now, third level will cover all little bit different, sorry, little bit advanced topics. I will not say too many advanced, but there are few advanced topics that we will start looking at right after we are done with this. And one of them is going to be like file IO. When I say file IO, I hope you might have already seen or might have already heard, like when you are using computers, you are kind of persisting your information inside your secondary storage. We call this as hard drive, for example. Now, how do you persist your data? How do you store your data? You store your data in terms of files. And this is what we are going to learn here in file IO. Excuse me. Like a reading file, maybe I'll just say operation like a read file or a write file or update file, or something like seek file. And there are so many other options available out there. Now, this is all depends again on you what kind of operation you want to perform, but this is all that we will see inside the file IO. Now, remember one thing, the file IO is going to be important for you at least when you are going for machine learning, or maybe you can go for something like data handling scenarios, because there your data will be stored in files, or later in machine learning, we will be storing our models again into the file. So again, if you are willing to learn Python for pursuing the careers in maybe data science or image processing or testing, this is again going to be important for you, because most of the times the configuration will be read from file, the configuration will be updated into file, the models will be saved into the file or loaded from the file, so on and so forth. So this will tell you how we can deal with the files, reading file, writing file, so on and so forth. Okay, now once you understand the file, we'll turn our attention to another big and very important topic, not only in Python, but in all languages, which is known as object-oriented programming, OOP it is known as. To be honest, I think you might have heard about this. There are two types of programming. Now, not two, there are many, but two are very important programming paradigms. One is called as a procedure-oriented programming. From here to here, whatever that we are going to learn, that will follow the procedure-oriented programming. In a sense, we'll be focusing only on the functions. Procedures. Procedure means it's a function. So that is the reason why it is known as procedure-oriented programming, or POP style of programming it is known as. Now, this is okay, there is no problem with that. But when you start writing too many functions, it becomes very difficult for you to reuse them, because most of the times the data and the functions, they are not getting bound by using procedure-oriented programming. You can't reuse them together. If I want to reuse the data along with all the functions which are required to perform operations on that data together, I have to turn my attention to something called as object in OOP. So object, it means it is a collection of data plus the operations that you want to perform on the data. This is called as object. And dealing with the objects will be learned inside this object-oriented programming. Our orientation will be changed. Orientation earlier was function, focus earlier was function, or maybe you can say we were thinking about developing our applications or logic in terms of functions. Now we'll change our paradigms and we'll go for something called as object-oriented programming. There, those famous terminologies will come into picture, something like encapsulation, then there is something called as abstraction, then there is something called as a polymorphism. Those are pretty much jargons, polymorphism. And there is something called as inheritance, and so on and so forth. There are many. So when you talk about the object-oriented programming, these are pretty much important jargons that you have to learn. And of course, if you are going to appear for some interviews for different companies, they definitely will ask these questions in interviews. And of course, don't worry, while learning the topics, we'll talk about the interview questions also, and we'll also see like how should you prepare for this topic from both interview perspective and your career perspective. So we'll start giving you all these ideas right inside the topic itself. And of course, I already have prepared almost like 90 different questions for interviews on different topics. We'll share all of them along with the answers as well, like how should you answer the questions and what things you should consider while answering the questions in your interview. So this is pretty important topic for your interview perspective, OOP. And believe me or not, Python is the simplest language where object-oriented programming can be implemented without having too much pressure. If you go to Java, I mean, learning OOP in Java becomes a nightmare sometimes, or C++. C++ is like, it's like this, So probably it's a very much difficult to understand C++ program. And then on top of it, if you start learning OOP in C++, it becomes again a nightmare there. But in Python being a very simple language, very simple, in a sense like simplest language if you ask me, the learning OOP language, OOP concepts, very simple. So you can understand OOP concept better in Python. That's what my experience here is.
ओके तुम्ही
Okay.
मीटिंगचा मग मेसेज करा. मी तुम्हाला आज सगळ्यांना अलाउ करा तरी
Okay. Sorry. He must have got unmuted. Okay. So this is what I'm saying. So when you are going for OOP, OOP is a very important topic out there. Now, once you understand OOP, we'll start using OOP in different perspective. One of them is called as an error handling. Error handling means sometimes, when you are writing the program, you never know so when it is going to crash. Like for example, let's say here it is. So for example, if I'm dividing, let's say 10 by 2, I know the answer is going to be equals to 5.0. But if I divide this 10 by 0, what is going to be your answer? To be honest, in our mathematics terminology, this is called an infinity. But in most of the languages, this is going to generate an error and your application will crash. Now, in such scenarios, when my application crashes, it's not giving a very good indication to my user. If the user says the application is crashing, user will definitely don't want to use your application. So in which case, I do not want that to happen. And that is the reason when there are some errors, we want to handle them and let my application not crash at the moment. This is called as error handling. This error handling can be done by using something called as an exception. I mean, in Python, we call it as an exception handling or error handling as well. So this is done by using exception handling. And again, there are many keywords out there. For example, there is a try, there is except, not except, except, something like that. Then there is something called as the raise, precisely, there is an else, so on and so forth. So basically, you can use any of them. And there is a finally also, if you want to go for. So this is a kind of, set of keywords that we will be using, right, to handle those something called an errors or exceptions out there. Okay, so again, this is going to tell you like how we can deal with those issues at the runtime or dynamically. Now, once you understand all of this, this is the last part of my third part. You can call it as a fundamentals, or maybe the language. Language details. Like this is called as modules and packages. Most of the times, you will observe the code that you are writing will be reused or will be required to be reused in multiple different applications. I mean, sometimes it is sometimes it is visible that the code that you are writing, I'm going to use that code in many other applications as well. So writing or copy pasting that code is not good idea. So instead of doing it, we generally develop the modules and packages so that we could easily reuse our code in many applications out there. So reusing the code or reusability is what we want to achieve by using modules and packages. Generally, what happens here is if you are developing an application, let's say in machine learning, so there are many functionalities which we are going to use in all machine learning applications. So instead of writing that code again and again, there are many packages or modules which we can directly download or reuse and start writing our machine learning code. For example, in machine learning, there's a scikit-learn or there's a TensorFlow, there's a PyTorch, and there are a bunch of other packages out there. Now, pretty much I can say not the whole list, but pretty much important ones. There are standard packages and there are external packages. Now, standard packages will include something like, OS package or RE package or JSON package or a datetime package, and so on and so forth. So these are the standard ones and we have to use them in many different programs. So we will talk about OS, RE stands for regular expressions, JSON, datetime, CSV also. Or maybe we can do that later. So maybe we can see whether it is needed or not and accordingly we can change it. But these we have to use them without fail because these are very important ones based on the logic that we will develop in the real world. From external category, there are many that we have to focus on. One of the most important is something called as NumPy. So NumPy is again one of the de facto standards in Python. I mean, I don't know why these guys have still introduced, or sorry, still included Python, included NumPy in the Python. It is so important. Every Python developer, irrespective of the domain that you want to use a Python in, will have to know NumPy, because NumPy is way better than the default collections like list or something I mentioned earlier. So NumPy is going to provide you something called an n-dimensional array, and which is going to be faster, memory efficient, and that is the reason why when you go for machine learning by default uses NumPy, irrespective of what kind of programming that you want to do there, like machine learning or artificial intelligence, or you can say deep learning there. NumPy is the default standard out there. That's why it is considered as a de facto standard in Python, NumPy. Now, other than NumPy, we will be focusing on something called as Pandas. Now, those who are willing to go to data science, those who are willing to go to, let's say, machine learning, for example, for them, Pandas again is going to become a bread and butter, because without Pandas, you will not be able to load our data. The very next topic here is something called the data handling. And for data handling, we have to load the data, and the data loading will be done by using Pandas, in which case we will learn series, something called the data frame, panels, so on and so forth. And we'll see like how and why Pandas is known as Excel on steroid. That's what the Pandas is known as, Excel on steroid. Okay, so NumPy and Pandas, both of them are going to be very important for us to understand how the data can be handled. But not only handling data is important, we have to also understand the data. And for understanding, visualization is one of the most important thing to see like how the data is looking like, or how we can deal with the data, how we can understand the data. This is done by using another package called as matplotlib. Sorry, it's called as matplotlib. This is generally used for visualization, like different charts. There's a pie chart, bar chart, histogram, so on and so forth. So we have to use the matplotlib for visualization purpose, charts purpose. These three are going to be required in any case for machine learning, and sometimes in terms of OpenCV, like image processing there. So this is a kind of a group which is de facto standard again in machine learning perspective. Now, these are the simple ones. We'll see a couple of more if time permits, but that's not guaranteed because it depends again on the time, in fact. But these are something that we have to explore. What I'm saying, the other ones, there is one something called as a Seaborn. If time permits, we'll talk about that. Then there is something called as a Plotly. All of them, Matplotlib, Seaborn, and Plotly, all of them are used for drawing purpose, drawing in a sense, charting, or let's say graphing purpose. These all are kind of provided for visualization purpose. Okay, now that you know what kind of external packages that we have to learn. By the way, in Python, there are more than 300,000 packages, and that is the reason the Python can be used in variety of different domains. It can be used in testing domain, or image processing domain, machine learning domain, testing domain. There are many other options available out there, but this is possible because the external packages are available. And how can I forget that? There is one more that we have to see, something called as a Selenium. Those who are willing to go to testing, for them Selenium is going to be again the bread and butter. So this is modules and packages here. This is something that will help you to use Python in other domains out there. Okay, fine. Now, once you understand this, we'll go into our last portion, or last, maybe you can say the module in this entire course. So I kind of divided this into 4 different parts. From here to here, we are talking about the first part. From here to here, we are talking about the second part. From here to here, we are talking about the third part. And from here to here, we are talking about the fourth part. Fourth part is something like which is going to be based on all the things that you have learned so far. Like for example, we'll go for data handling. Data handling means loading data, or maybe you can say persisting the data, or you can say modifying the data, so on and so forth. So this is where we'll again use NumPy and Pandas for the same reason. Okay, for handling the data. Now, when I say handling, the data will be loaded. So this is like a loading data or manipulating data. How do we do that? I'll explain it later, but this is the manipulation and the visualization. visualization. And for visualization, as I mentioned, we'll be using that matplotlib or seaborn or plotly. That's called the data handler. Okay, now when we talk about the data handling, as I mentioned, we have to persist the data. Data persistence can be achieved by using variety of ways, but the one which is most important in today's world at least, it's called the database connectivity. Means if you are writing a Python program and if you are expecting some users input, I want that input to be persisted somewhere. How do I persist my data? How do I persist my users information? I can either do it in file, which I mentioned earlier in the file IO topic, but here we are not going to talk about that. Here we are going to talk about the database. So how do I connect my application to the database like MySQL? We are not going to learn MySQL here. I'm assuming that you know at least fundamentals of MySQL, so that if you want to connect your application with the MySQL database and persist your data, how do we do that? This is what I'm going to show you here. The MySQL comes under RDBMS category. RDBMS stands for Relational Database Management System. But again, I'll not stop there. I'll go for something called as a Mongo, which is not only my personal favorite, but also considered to be the de facto standard in NoSQL databases. So those who have heard about that, well and good, you will see like how you connect your application with the MongoDB. If you haven't heard about this, no problem. I'll give you a short demo of what MongoDB is all about, and then we'll connect our application to MongoDB. Both of them are important. One is RDBMS category, one is the NoSQL category. So you will get an idea like how do I connect my application to the RDBMS as well as NoSQL database? What is needed there? And again, this can't be done without using something called the packages. So we'll be using PyMongo for MongoDB and SQL. I mean, by default, it's not SQL. It's called the MySQL package given by MySQL there. So this is how we will be connecting our application to the different databases. Okay, now once you know like how the database is connected, how we can persist our data into database, we'll make that data available for our other type of applications. This is done by using something called as a web services. In today's world, there are two important terminologies that we use. One is called as a front end and another one is called as the backend. Front end means like what user can see. Like for example, if you're using Amazon to purchase something or for e-commerce purpose, what you see on your browser is called as a front end. The front end is showing you some information, like there are hundreds and thousands and millions of products you can see in Amazon. But where are these products coming from? Those products are coming from databases. Like for example, they might be using MongoDB or Redis, for example. So the data is coming from the database. But how your front end, how your website is fetching that data, this data is getting fetched by using something called as a backend. So if you just go for a high level overview of it, this is my website, for example. Maybe I can say this is my website, or this could be my application, mobile application here. So this is a mobile app. So you can see Amazon, for example, it's available in two different ways. You can directly go for a database, you can go for a mobile application, download it on your mobile, or you can also browse it on the web, on the browser. But have you not noticed it? Whatever you do in one, you can always see in another. Like for example, if I open the website in a browser, for example, in that case, I can add one product in my cart. I can see the same product being added in my cart in mobile application. Now, how is it possible? It is possible because both of them talk to the same backend. And this is what I'm talking about. Backend means it is a kind of, you can say, a server. I'll call this as a backend right now. And this backend, the one that I'm talking about right now, is connected to the common database. So once you understand how this database can be connected to your application, which is running somewhere here on that backend or the backend itself, you will understand you are connecting from website or mobile application to that backend, you always will get the same data. And that's a secret that all these applications today are showing you same data in different type of applications there. And this is what we'll be developing inside this web services category. This is what we will be focused on. Backend implementation. How do we do that? This is done by using something called as the REST APIs. The REST APIs are those with which we can consume that data on the front end side. This is called as a front end. Front means the user is going to see that. So user can either see the website or user can see mobile application there. So what user sees is called the front end, and what user does not see is called as a backend. So in this particular case, the backend will be implemented by using REST API, and for this we'll be using a very famous package called as a Flask. I should add that right here also. So that's called as a Flask. So when I say Flask, a Flask is again industry standard, a web server which is going to provide you all the database related stuff like REST APIs for your front end. So I know you do not understand anything right now. Just listen to me carefully. I'm just putting up the dots here as we'll start working on the different topics in different sessions or upcoming sessions. You will start connecting the dots and then you will get the entire application there. So you can't connect the dots looking at the forward. You can always connect dots looking at the backward. Steve Jobs said in one of the keynotes there. So what do you mean by this? We'll understand that later in details. But right now, this problem we will be solving by creating one backend. This is called as the backend here, and backend will provide the data to my both website as well as mobile application there. Again, Flask is not the only option, and there are many options available out there, but Flask is going to be considered as a very as a kind of de facto standard, you can call it as, or it's a very simple to use, and that's the reason many companies prefer using Flask, and that's the reason why we have included that here in our application. Okay, then we'll go for something called an application testing, where we'll understand how to test an application. Developing application is crucial, it's important, but not only developing is important, you also need to say whatever that you have developed is working fine. And this is done by using application testing. I'm not talking about something like a manual testing. Manual testing, you can do it yourself. I'm talking about something called as a test automation. When I say test automation, there are two libraries we'll be focused on. One of them is called as Selenium, which I already have mentioned here, and another one which is considered again important for Python developer, called as unit testing framework, PyTest. PyTest. I mean, in today's world, we are using TDD approach. TDD stands for test driven development, meaning if you are a developer and if you are developing something, it becomes important, it becomes you become responsible for your own code. So it is important for you test your application before you say you are done with it. This is done by unit testing, and that unit testing can be done by using PyTest. So PyTest is going to be important for you to know whatever that you have developed is really working. This is called as unit testing. More on that later. Unit is a function, so it's called the functional testing. And this functional testing or unit testing is the responsibility of a respective developer. So if I'm developing something, it's my responsibility to test it and then say I'm done with it. Otherwise, if it is not working, what's the point of it? So PyTest becomes again a unit testing framework, unit testing package, which will help us to make sure whatever I've developed, it's working really fine. Now, when you are working on the project, let's say you have developed your application, it's working really nice, it's solving many problems, it's really something that your user will want to use. But the problem here is the application that you have developed is running on your machine. Your user can't use that. I mean, imagine you are developed your application, you are testing it on your machine, everything is working fine, but your user is sitting there in USA. How can your user access your machine from his environment? It's not possible, right? And that is where you are going to make sure your application that is really working fine, you want to put it somewhere my user can access. This is done by using something called as deployment. And I'll show you two types of deployments. Here I'm not going to talk about the cloud. I'm not going to talk about containerization. I'll just show you how it is possible for you to make sure the application is getting developed on a cloud. I'm not expecting you to learn everything in the cloud, but at least there are a few steps you can follow and get your application deployed on server. And for this, I'll be using AWS. For those advanced users who already know this, for them, showing you this example as well by using something called as a Docker. I'm talking about containers, or this is called as a containerization. So those who know containerization, those who know Docker, for them, we'll see how do we run this application inside container as well. So this is Again, very you can say very high level, or very, you can say, the deployment oriented stuff. We will not learn Docker, will not learn cloud here. I'll just show you the steps. How do we do that? Okay, I'm assuming that you might have seen anywhere or everywhere, or you might have heard about that. And if you are willing to know how do we do this is the way you can do it. Otherwise, learning cloud itself will take 2 weeks. Learning Docker will take at least 1.5 week. That's not what we are here for. We are here for Python, and that's the reason this will be a small session where I can show whatever that you have developed. It is running on server that can be accessed by anyone in the world. This is what I'm talking about. The server can be accessed anywhere in the internet. So this is done by using the deployment. And finally, to prove that whatever that you have learned, it's really working, and that is based on the real world, we'll be developing 2 capstone projects. I'll call them as a capstone right now, but believe me or not, these are real world type of projects. There are 2 projects that we'll be developing. I'll not disclose them right now, but there are 2 projects that we'll be working on. One of them is going to be data oriented, like the analysis stuff. Like when I say analysis stuff, you are going to bring the data by using, or by something called the web scraping, by using Selenium. Sorry, by using something called the Selenium, we'll scrape the data. Scrape means we are going to download the data automatically from different websites, and we'll see how we can analyze the data by using something like the Pandas, for example, and then we'll kind of create a report on that, a simple report, that will show you many different aspects of the data by using different charts. That's a data oriented one. And second one, it's the front end and back end. Front end will be front end and the back end. Front end plus back end. Back end, as I said, we'll be developing that using something called the Flask. And I don't know, but we'll see how we can develop the front end later. Maybe it could be HTML, for example, or we can go for Streamlit. I'm not sure, but let's see. I've not decided to go for it, but anyways, the topic has come here. Why not to go for that as well? Let's go for
For
it.
web scraping, we are not going to use Playwright or like something else, other stuff.
Now, there are options available, but we'll be using Selenium. Selenium is a very simple, and that we already have learned earlier. That's the reason we'll be using Selenium for web scraping. For scraping, there are many libraries. There is something called as Scrapy as well in Python perspective. So you can use that also if you want to, but we'll be using Selenium because Selenium is very simple. There's another one, something called a Beautiful Soup. So either you can go for Beautiful Soup, Selenium, Playwright, Scrapy. Choice is yours, but I'll be showing an example of something like a Selenium. And this is something that will give us a huge amount of data, which we can analyze by using the visualization purpose, like using the using the pandas, we'll load the data, but using matplotlib or seaborn to create the different charts of it. So we can analyze it. Okay. And again, in front end and back end, front end will be developed by using Streamlit, where the user will enter the data, blah, blah, blah. And using Flask, we can store the data into the database or load the data from database. So this is what we will be covering here in the capstone projects towards the end of the session, end of the course. Oh my God. So there are so many things that we will be covering throughout this entire course. So probably, I don't think if you learn all of these topics, there is nothing left in the Python. I mean, of course, after this, when you want to use Python, things will change, depend again on your project, but that's a project specific stuff. From Python's perspective, all of these things will give you more than enough idea about how we can use Python in different perspective, different domains, different type of applications, and then you can start developing your logic. Okay. So I hope you have got to know like what different things that we are covering. If you still have got any question, please ask me whether we are covering that, whether we are covering this, or whether we can do it if time permits. We definitely want to go for that. Hemant, yeah, we are covering the most of the libraries. Yes. By when we'll be covering the collections and collection topic? I think end of the next week, hopefully we'll start with the collection. Okay, maybe next Thursday or next Friday. Friday, I think we'll start talking about the functions. So something like a collections. Okay, so that's what I don't know. That's a plan that I'm having right now. But hopefully next Friday we'll start with that. NoSQL, little bit more details about the new course for NoSQL Mongo. Yeah, we already had that course earlier, but we'll see if it is possible in one Saturday, Sunday. We'll arrange a workshop on Mongo. If you are willing to go for it, definitely you can join there. Yep. Rishikesh?
If there is Mongo workshop, please let us know, sir.
Of course, we will. We'll put a message on your group, so don't worry. And that will give you an understanding of how the MongoDB can be used or how we can, use Mongo in the real world. But that is going to be a Saturday, Sunday only, not in between the weekdays. We'll see when we can arrange that. But we'll be arranging in this course itself. So it will give an idea. And before, of course, we will see that before we go for database connectivity, I'll make sure that MongoDB is covered somewhere. Okay.
And sir, can't we go deeper into web scraping part? Like you told that about Playwright and Beautiful Soap.
See, I can, there is no problem from my side, but given the time restriction and given the, the time that we have given, if we start focusing only on the web scraping, we'll not be able to give justice to other topics as well. That's the reason. Okay. If you want, we can see it in 7 separate sessions where I can have, not in our day-to-day, but we will be having some extra sessions, something like on Saturdays or Sundays. We'll see when it is possible. And then we can go for it. Okay. But that's something that I don't want to, because see, data scraping is important, but it's not like everyone wants to use it, So in that particular case, if you are having a specific requirement, we can go for that, but as a separate session, not inside this. Okay, we'll see. Sorry, Rishikesh, you are saying like I'm from data engineering background. Okay, I wanted to understand how much course this will help me. When you are coming from data engineering background, I think you already have seen there is an entire topic that I mentioned here, something here, data handling. This will give you the enough idea about how we can load the data, how we can manipulate the data, how we can visualize the data. And this is the job of a data engineering. The Pandas itself will be putting one entire session on Pandas, which will help you not only to understand the data, but also manipulating the data. Like, for example, you can add a column, delete a column, fix the data types, so on and so forth. This is the prerequisite of a machine learning. So when you are going for machine learning's main job, or before you go for machine learning, the main job is to cleanse the data. This is called the data cleaning, data cleansing, data scrubbing, So in this particular case, the data that you have downloaded or scraped, for example, which is in a bad shape, you want to convert it in a shape that you can use it in a machine learning. So data engineer's main job is to handle that data in a variety of ways. This is the entire topic that will help you to understand how do we do that. And of course, for understanding this, these are the dependencies. So that's how you are going to look at it from the data engineer's perspective. Okay. Instead of Flask, can we go for FastAPI? We can. I will not mention that right now, but we'll see if we can finish Flask in one session. We can have within maybe one session itself, we can go for talking about the FastAPI. Okay, we'll see. I prefer using Flask because Flask is industry standard. That's the reason. But if you are having some requirement, we'll see if it can be catered inside a session itself. Okay. Once you understand Flask, using FastAPI is not going to be a big difference because both of them are kind of following the same philosophy. Of course, coding will change here and there, but you will get a basic idea here. But let's see if time permits, we definitely will go for that. Okay. Dharmarajan, a wonderful range of the topics covered will get integrated throughout the course. By the way, I didn't mention that, but whatever that I'm drawing here, whatever that I'm going to write here, everything will be committed and pushed to the Git repository, which you can get every single day. So once the session is over, I'll commit it within next couple of minutes or maybe next within some time. You definitely can download that or pull that on your machine and start practicing it. Definitely yes. Kulvinder, you are from a network domain. I have no idea about languages, and that's the reason, we will be not starting with the Python, sir. We'll be talking about the fundamentals. So our topic of today is like a language fundamentals. We'll be starting with what do you mean by language, where it is coming from, and so on and so forth. So don't worry, you are already covered. Okay. I'm expecting you to be a plain or freshers who do not know programming at all, and that is where we'll be starting because I know most of you are coming from colleges who already have just passed and learned the languages theoretically. So learning language theoretically and working on a practicality based approach is going to be totally different. So Kulvinder, you already are covered. Okay.
Thank you, sir. Thank you so much.
No problem. Heyman, Cassandra is going to be a very specific topic. We are going to use MongoDB for now. If needed, we can see how we can arrange a session on Cassandra. Bhushan, I tried multiple times to learn the Python, but failed to complete and hope this time you will get a good output. Depends on you, not on me. I'm going to cover all the topics. If you sit every single day without missing and practice every single day, focusing on that. And believe me, more than 1 hour, you do not need to learn on Python after, of course, the session is done. You have to pay attention to the session. You have to do the coding along with me if it is possible. And if you are going to, practice on your own after the session, 1 hour a day, I don't think you will need anything other than that. So not only completing it, Bhushan, is important, but also having a hands-on is important enough. So we have to just spend 1 more hour after we are done with the session to get more out of it. Okay. But yeah, you should. Chaitanya, what about those people who are from PG DAC background, whose course is going to be helpful? If you are coming from PG DAC, I definitely would recommend you, because these days in many interviews, if you already say like we are coming from DAC or you already have completed the DAC, they will definitely ask the questions on, at least the basic questions on machine learning. And when the machine learning comes in, Python by default comes. So it is going to be important for you people as well. Amit, you are from core Java developer working in a Bank of America. Wonderful. We are moving our system from Python, moving our system with the Photon best. Will it help the OOP Python? Once you understand OOP in Python, I can guarantee you, you will not have any problems with the OOP in any other languages. Learning OOP in Python is the simplest way to learn OOP. I mean, this is something, again, I'm telling you with my experience. But I mean, I've learned OOPs in multiple different languages, like C++ is what I started with, Java, and so many other languages. But I found Python is going to be very simple, and Python is very simple. So learning OOP will give you not only the OOP in Python, but also give you clarity on what OOP is, And I'm telling you again, OOP in Python is way different, out of the world experience you may see here. So definitely it will help you to learn OOP in other languages as well. Yes, Harshit, after this course, what time it will take to learn machine learning? It depends on you. I mean, I can't tell you like how much time you will take, but after this, there are 3 more courses that will be launching. One of them is statistics, another one is machine learning, another one is Gen AI. I mean, Gen AI is like AI. It's like deep learning, for example, or machine learning, for example. So there are 3 different courses which are going to help you to understand machine learning from end to end, starting from the statistics to the machine learning, because machine learning is nothing but an extension to statistics. So you have to first understand statistics, and then only then you can understand the machine learning point of view there. Okay. Are we going to cover coroutines? I'm not willing to, because it's going to be very advanced topic. I've not included aspect-oriented programming as well. If time permits and if you still are willing to learn something new, I definitely will include that. But remind me towards the end of it. If it is possible, we definitely will talk about that. Okay. Coroutines, aspect-oriented programming, iterator, generator. There are a few more advanced topics. I did not include them here because these are very rarely used in the industries, But again, if you want, remind me towards the end of it, we'll definitely talk about that. Okay. Chaitanya, will you be kindly touch the base upon the different types of data? Of course, yes. Without that, how can we? I wish to particularly learn how to decide the packages to use depending upon the type of the data. Definitely. That is something which we'll be doing in the data handling part itself. Okay. Nilesh, do we have small session on the PySpark? No, that's not the intention here. PySpark, it comes under big data. There's a separate course on that, So PyTorch, PySpark, we'll not talk about that here. Yes, Nilesh.
Sure. Fine.
Yeah. Abhishek, how soon the recording will be made available, just in case if you miss a class? When it's a morning session, maybe we will stop around 10:30. So it will be available maximum around maximum 12. So you can start watching it after 12 o'clock. Okay. Yeah, I understand. Otherwise, the link is broken. Absolutely. Okay. Harshit, I think your question is already answered. Aarti, could you tell us like what are the opportunities available in the market based on the Python? I'm automation engineer, MNC wants to switch my career to the current market standard. You said it's the best path to learn Python. If you are coming from automation, that means for you, Python is going to be not only important, but also mandatory, because in testing automation, you might have seen that people prefer using Python. Not only it is because it's a simple, but there are variety of packages available, which we can use here while testing it, like PyTest, something like a Selenium, and there are a bunch of other options available out there. So not only it is important for you to learn Python, but sometime later you will feel it is going to be mandatory. Without that, you can't do many of the other stuff that automation engineer has to do. So yes, that is going to help you to understand the automation testing as well. Okay. Omkar, you have completed PGDHD from SunBeam. How learning Python will help me in embedded programming? As I mentioned, the Python is going to be used in multiple variety of domains. Embedded domain is where it shines. Flask I mentioned here, it is very, it's called as having a very low latency. And because of that, generally, if you are in IoT, people prefer using Python. I mean, there are multiple reasons, but Python, it is preferred in the embedded domain because it runs on a very small, let's say, for example, you're taking an example of Raspberry, so Raspberry Pi. So it will not only run on your desktop, it will also run in Raspberry Pi as well. Raspberry Pi being a very small module that can also learn there. So that can also run there. And that's the reason why it is considered as a kind of a language preferred in the preferred in the embedded domain. Okay. Yes. Amit, I think I already have mentioned here, Pandas has already been included. We will be having an entire session on Pandas. Okay. Don't worry. Okay, I think all of your questions have been answered, I believe. So now you know what things that we are going to cover. What is the entire canvas that we are going to touch base. Okay. Now, before we start with the sessions, before we start with the actual topic, I will quickly give you my introduction, so you know who you are talking to, or at least we can set up a kind of a tone there. Okay. So my name is Amit. I'm having more than 18 years of the experience in both teaching as well as developing. I myself work as Associate Technical Director here in SunBeam, and I'm also working as freelance developer. So actually I live two lives. So one life, in the morning life, I deliver sessions here in SunBeam, and the second half, after 2 o'clock, I become a kind of a, you can say freelance developer, working with different clients. I have my other clients coming from the US and the UK, and then I develop multiple different type of the applications with them. So mostly when I say like I'm developing applications, I started my development journey way back in 2007 with iOS, when not with the iOS in 2007. In 2007 I started with .NET for the first time, and then I stopped working on .NET because I hate Windows. That's the reason. Then I switched to 2008 when iOS got launched, or iPhone got launched. I started working on iOS and Android development at that time. Then I started developing the websites and bunch of other stuff there, like using PHP. Mean stands for MongoDB, Express, Angular, and Node. And Mon stands for it is a React. So these days the development I do, most of them is like React based. Also use Angular sometimes, but React based development I generally do. Generally, when the project I start working with, I decide the language from these categories like C, C++. Rarely use them today because we most of the times are using the website development or mobile application development or ML applications, or the agentic AI and so on and so forth. So I have to use Python a lot. Other than that, I use JavaScript and TypeScript. One for React, that is for JavaScript, and Angular I use TypeScript a lot. So that's a TypeScript. Go, one of my another favorite language that I use for sometimes for backend development. Swift for iOS native development. Kotlin for Android native development. PHP has stopped working these days because PHP, there is no project coming up and people generally hate using PHP, including me as well. But that's how it is. Now I started with PHP earlier as a web development, but nowadays we don't use it. Now, other than development, I also do the DevOps part as well. And this is what my favorite part as well. I mean, other than development, DevOps is also my favorite part, which I use many different tools out there, like CI/CD pipeline using Jenkins, our GitHub Actions, Argo CD, very important points when you are going for automation there. When we want to create the infrastructure, use Terraform and Ansible. Use AWS as my go-to cloud. So whenever something requires to be done on the cloud, I use AWS because AWS is very famous. It has already captured more than 60% of the market in the cloud industry. That's the reason I use AWS. Of course, I use GCP and Azure as well, but not that much. AWS is something that I generally go for because most of my clients' projects are most of my clients are using AWS. So I have to cater to their requirements. So that's the reason why I have to use AWS there. Docker is one of my favorite platforms where I use it on my daily basis, and to run my applications using Docker, I use Kubernetes and Docker Swarm. Docker Swarm rarely. Kubernetes is something that I use a lot in the real world perspective. I've got many certifications out there. Few of them I mentioned here. A couple of them I could not have space, that's reason I did not include them here. So this is from Kubernetes perspective. So Kubernetes, I've got both application developer and administrator. These are two kind of, you can say, pretty much you can call this as a gold mine when you are going in the DevOps category, because those who know Kubernetes, they generally are considered to be valuable in the DevOps category. So got both of them here. From Jenkins perspective, got Jenkins certified as engineer as well. Docker certified associate from Linux. Linux is my second favorite operating system. First one is the Mac, of course, the one which I use on a daily basis. Second one is the Linux. You will not see Windows anywhere. Windows, I don't use it, and I don't like it. Another one is Security Plus. When being a developer, developing applications in the real world, I need to showcase that I know the security principles, because without them, no one will come to you and ask you to develop applications. Because in real world today, if you look at it, data is very important. Data is considered as oil in the industry. It's not the oil who's going to make money today. It's the data. And that's the reason protecting that data becomes a prime responsibility of a developer. So how do I do that? This is done by using the principles which I have learned inside CompTIA Security Plus. So there are others like RHCA, RHC, or it's not RHC, RHC. I completed in 2003. CCNA I completed in 2003 or 2004, I believe. Then Oracle certification like OCJP completed in 2008 almost, but I don't use them because it's already been expired. So I don't want to worry about that anyways. So these are the different certificates that I have gotten, and probably you are in a good hands. That's what I just wanted to convey the message here. So do not worry about this. Whenever you are having any doubt from not only from these topics, but any other topics or any other tools, definitely you can contact me on WhatsApp. Okay. Don't expect the answer immediately. When I get time, I definitely will come back to you. Anyways, so hopefully you have understood what that we are going to see here in the entire course. Who am I? Now I think we are good to start with the application, or we're good to start with the course. Guys, are you all there? May I get to know if you are willing to continue further?
Yes, sir.
Yes. Okay. At least someone is saying thumbs up. You don't have to answer every time, but at least just give me thumbs up, thumbs down. So at least I'll know whether you are really available there, looking at the count 49 right now, I'm not sure like how many of you are still in front of your machine. That's the reason I just want to get a confirmation whether you are there. Okay. So as I mentioned, I'm assuming that you are freshers and you do not know anything about the languages. So we start with what exactly a language here is. So it's like language fundamentals. Those who already have used other languages, for them, it's going to be a revision. Okay. For those who are using the Python as a first language, and if they do not know what language is and what exactly do, this is for them. Okay. Okay, so let us understand what do you mean by a language, why it is required, and how we can use language, and how we can see different languages are available in the computer industry. Now, first thing first, like I'm talking to you using English as a medium, or you can use Hindi as a medium, or you can use Marathi as a medium. So language is nothing but a medium to interact with someone in the real world. Similarly, when I say language here, I'm talking about a computer language, of course. So in computers, if I want to interact with computer, if I want my computer to do something for me, if I want to process some, maybe if I want to perform some operations, if I want to do some kind of processing, I want to tell my computer how to do it. This can be done by using the computer language. So a language is a medium to interact with the computers. And this interaction will be done by a variety of ways. And this is what we are going to learn here. So a language is used to solve many problems by giving the solutions. When I say the solution here, the solution is nothing but the logic to solve the problem. Like for example, I can say, I want to check if the number is prime or not. So how do I tell my computer whether the number is prime or not? This logic will be implemented by using a program, and that program requires some syntax, and that syntax is given by a language. So basically, if I'm conveying my thoughts to you, I'm constructing the statements or sentences, and that sentences construction is governed by, or it's kind of given by the language. So similarly, my logic is implemented in the program, and the program is coded by using a language. That's where you can see the relationship between, let's say, English-like medium, English-like language that we use in the real world, and Python is a medium with which we can communicate with computer, explain the logic, and let the computer to do some kind of operations on behalf of me. Now, when it comes to the computer languages, there are many types of languages. For example, there is a machine language, there's an assembly language, and these are high-level programming languages out there, like general purpose, markup, and so on and so forth. Now, let us start with the machine language first. Now, generally, before we go for this, let me just explain this quickly. Before we go for understanding what is that machine level and other stuff there, let me first tell you what exactly happens when you are giving some instruction to your computer. So when you say you are having a computer, say for example, this is my computer, this is my machine, and in this machine, you can say we are talking about hardware right now. So let's say this is the hardware. Within the hardware, we are having the most important part, which we call it as the brain of our machine, called the CPU. Of course, there is a memory, or there is a storage, there is a NIC. NIC stands for network interface card. There is an audio card and whatnot, So there are many different components available on your hardware side. What the heck am I writing? Audio. So there are many different components out there, and we call this as a hardware layer. Now, if I want my application to perform some operations, I have only one component which does that job, which is known as a CPU. Now, CPU is a mechanical device which understands the language of current, electric current, I'm saying. So if I'm passing some current, let's say 3 volts or 5 volts, for example, to the CPU can perform some operations using something called as registers. A CPU is made up of something called as a registers. You can think about registers as maybe you can say the compartment in the CPU where the data is stored, and then you can perform some operations on that data. This is what the registers, or this is what the CPU is going to do for you. So CPU performs some operations mechanically. When I pass the right current, then the data stored inside the registers will get manipulated. This is what the CPU does. Now, it means if I want to check a number, if a number is a prime or not, I have to literally pass that number inside the register and send the current in such a way that the CPU can check certain conditions on the register and then give me the answer back. And this is how they started writing the code earlier, way back in 1950s. That time there was no programming language. That time they were dealing with the CPUs, or they dealing with the machines directly by sending the currents. But dealing with the current, it was very difficult for them. And that's the reason the CPU manufacturers decided that, hey, you don't worry about the current. You simply pass the data in terms of something like the binary code. It's like a 0, 1, 0, 1, 0, 1, something like that. 0, 1, 0, 1, 1, 1, 0, 0, so on and so forth. So we call this as a binary. And this can be done by using something called as machine language. Now, what is a machine language? Machine language means it is like the binary language. The CPU can understand the current, that's fine, but I as a human being cannot deal with the current every single time. I mean, sending different type of current becomes a nightmare for me. And that is the reason why the CPU manufacturer said, don't worry about the currents, we'll manage it internally. You just send what kind of instruction that you want the computer of the CPU should perform by using the binary language, like 0, 1, 0, 1, 0, like that. So when I say 0, a particular current will be passed. When I say 1, a different current will be passed, and CPU understand what kind of instruction that you have to do. Of course, there is a data bus, there is address bus, and so on and so forth. I'm not going into that details right now, but let's say, keeping all of this hardware details aside, we can simply say, in this particular case, you are kind of saying the current will be controlled by using the binary language like this. Wonderful. So after dealing with this current, I mean, they said, oh, using binary language is way simpler, because manipulating current is going to be difficult. Instead of writing that 0, 1, 0, 1, 0, 1 becomes very simple. And that's how they started using binary a lot. But after some years, they realized writing code in binary was also difficult. And that is the reason they came up with something called as mnemonics. And these mnemonics are nothing but the assembly language. This is my assembly language. Assembly language. And when I say this is my assembly language, in this case, this is my assembly language. In this particular case, we are sending not in terms of binary, we are sending in terms of pure English-like words. Like, for example, add A1, A2, for example, I'm saying, which means there is a number in A1, there's a number in A2. You add these two numbers and store the data in A1 register. These are the registers, for example, A1, B2, or maybe I can say A1, B1 or A2, B2, something like that. I go for A1 and B1, for example. So in this particular case, you are sending an instruction and you are sending where the data relies. This type of instructions will automatically get converted into binary which will get automatically converted to the current, and then CPU will perform all the operations that you want to perform. And that's how the assembly language started coming into existence. By the way, the CPU now can understand the assembly language because every CPU is equipped with assembler that is going to understand what instruction that you have sent, and then it converts into the binary, and then it converts it into the current. I don't have to worry about how the binary and current system is working inside the CPU because I'm not bothered about it. What I, as a developer, is bothered about, how can I simplify my life by using the assembly language here. But understand this now. When you talk about CPU, if I say this is what I'm kind of dealing with right now, CPU, and CPU is the one which is the only component in your machine which is going to perform some operations. The CPU comes in different families. When I say families, you can call them as an architectures as well. So CPU has got different type of architecture. There is something called as a RISC architecture, something called as reduced instruction set computing. Then there is something called as complex instruction set computing, or we can go for something like a Spark. This is not the PySpark. Someone said that last time. This is Sun processor architecture is known as. Then there is something called as maybe I can say MIPS and whatnot. There are many different processor families that you can use in variety of ways, in variety of domains. Okay. Now, when I say these are the different families, these are the different architecture. By the way, RISC is the processor which is now standardized by ARM. ARM stands for Advanced RISC Machine. Those type of processors you can find in mobiles. Okay. For example, if you are taking any mobile, just read its configuration and you will see it is using ARM6, ARM7, ARM8, so on and so forth. This CISC is nothing but your normal processor which you can find on the desktop. Could be something like Intel processor or something like an AMD processor. Those are called the CISC processor, complex instruction set computing. This is the category, this is the family, this is the architecture of the CPU, which requires more power, and that's the reason you can find them inside your desktops or let's say laptops, for example. So this is the category in which you can find the CISC processor, desktop and maybe servers, for example. Spark and MIPS, these are kind of application specific. I mean, this is now deprecated. No one uses that. This was used by Sun Solaris or the Sun machines. MIPS is still used in embedded technologies out there. So you can see every single type of, the architecture is kind of invented for solving certain set of problems. But now the problem here is when we are talking about CPU having different architectures or different families, every family has its own language, assembly language. In a sense, if I'm using an assembly language for a RISC that is not compatible with CISC, that is not compatible with Spark, that is not compatible with MIPS. If I'm writing my code using the CISC assembly, I cannot execute that code in RISC, I cannot execute it in Spark, I cannot execute that in MIPS. Which means when you are talking about this assembly language here, this assembly language is CPU architecture specific or architecture dependent, or someone says that hardware dependent. So you got your answer, Abhishek. In this particular case, if I'm having a CPU of RISC, I cannot execute the same program written in the assembly language in another CPU like a CISC. And this is the problem Dennis Ritchie and Ken Thompson have noticed. 1969, when Ken Thompson and Dennis Ritchie wrote their first Unix in the assembly language, they were using Honeywell and PDP at that time. So PDP-11 was the machine they used to develop the Unix, and they used the PDP-11's CPU architecture, or you can say assembly language at that time. Sooner, when they see like everything is working fine, they wanted to run that same operating system on another one, Honeywell, for example. But in that case, the Honeywell CPU architecture was different, which means the assembly language for that Honeywell's processor was way different than PDP-11. What happened then? Then Dennis Ritchie and Ken Thompson rewrote the entire Unix from one assembly to another assembly. They rewrote the whole logic because the instruction sets were different. And that is the reason why Dennis Ritchie thought, like, if I start doing it for all architecture, I have to rewrite the same logic again and again. What's the point of that? So I already have created the entire operating system. It's working really fine. Now, why should I write the same code again and again in different assembly language just because one assembly is not compatible with another assembly? What did he do then? He thought of something, and he, along with Brian Kernighan, created a, maybe I can say a completely different paradigms. This is called as compilation of languages. This is called as a compiled language, or I can call it as a compiler for now. This compiler, for example, I'm talking about the C's example here. Let's say I've written a program, say hello.c. This is my C program. If I'm passing that C program to my CPU, CPU cannot understand. So I'll pass that program hello.c to the compiler, and compiler emits all the assembly language on its own. Which means if I use the compiler for Sysc, it will generate the Sysc language or Sysc assembly language. Or if I use something like a RISC, it will generate the RISC assembly language. My hello.c will not change. This is the beauty of using compiled languages. I hope you are able to understand what am I saying here. In this particular case, when we are writing a code, let's say in C or C++ like code, or maybe in any other language where the compiler is used, you are writing the code only once, and the compiler is making it the CPU specific. Like, for example, the compiler will automatically understand, oh, this is assembly which is required for Sys. Okay, fine. It will create an assembly for Sys, or assembly for RISC, or assembly for Spark, assembly for MIPS, so on and so forth. This is the beauty of using this particular architecture. But have you seen that? This hello.c, the one that you have written here in C language, has to get passed to the compiler, then it gets converted to assembly language, then it gets to the binary, and then it gets to the current, and then CPU will understand what needs to be done. So actually speaking, the assembly and binary logic is there inside the CPU itself, but CPU understands only current, and that's why the assembly and binary will ultimately give the proper current to your CPU. I don't have to worry about this, nor I have to worry about this, because I can write my code in a high level language called as hello.c. This is exactly what happens here. I hope all of you are paying attention and all of you are getting this. Now, the point here is, when I'm kind of passing the assembly language directly to the CPU, fine, I can do it, but not today, because today we are having an operating system on top of hardware, isn't it? This is my operating system. This is my operating system. So when we are kind of doing this job in today's world, I cannot directly pass that assembly code to the CPU here, because I'm not talking to the CPU today. We are talking to the operating system. And that is the reason, when we are developing the application using C or C++ like that, this one, the assembly language, is not enough, because if I pass the assembly language to the operating system says, hey, I can't understand that. And that is the reason why we bring someone called as a linker. And this linker is the one which is going to create an operating system executable for you. This is going to create an executable. I'm not saying exe, I'm saying executable here. Every operating system has its own executable there, This executable will be passed to the operating system, and operating system from executable takes the assembly code and passes to the CPU. CPU gets converted into binary, current, and then it will start executing on its own. See the transition? Now I am kind of passing that executable to the operating system. Operating system gets that assembly part of it, and then it passes that to the CPU. CPU does all of that job for you. This is a way to execute our code. This is the way you are kind of saying, this is my, you can say, a way to get my code executed, get my code passed to the CPU. This is what I wanted to achieve. But see the problem now. When I say executable, the executable becomes operating system dependent. Why it is operating system dependent? It is because the linker, what I'm using here, this is the operating system dependent. In a sense, if you are on Windows, the C program that you have written here will get compiled down to assembly. No doubt that assembly itself is going to be generic enough. I mean, I can copy that assembly code from one operating system to another operating system, it will work. But because I'm on Windows, I'm using a I'm using a linker specific to Windows. It is going to create an executable on Windows, which is in terms of .exe, which is not compatible with Linux, nor it is compatible with Mac. Let's say, for example, instead of using Windows, if I'm on Linux, the linker here, which is like Linux linker, will create an executable Linux specific .o or .out, which is not compatible with Windows or Mac. So how do I solve this problem then? I mean, does it mean like I have to write the same code I have to write the code once, but do I need to compile 3 different times? Once for Mac, once for Linux, once for Windows? Yes, this type of development is known as native development. And I bet on this, you already have seen this type of development. Let me show you an example of it. For example, if I go back and if I say something like this, if I go for say download, if I say download Chrome, right? If I go for downloading Chrome, you will see, hey, what the heck? Okay, fine. So if I go to download Chrome, for example, in this particular case, you will notice downloading Chrome is available for different operating systems. Like Windows, it's a different package. Mac is a different package. Linux is a different package. For Chromebook, is a different package. For Android, it is a different package. And for iOS, it is a different package. Have you not seen what am I showing you here? So you can say that this type of development is called as a native development, and this will give you operating system specific executable, which is not compatible with any other operating system. And that's why if you are on Windows, you have to click on the right link to download the Chrome for Windows. If you're on Mac, you have to click on the right link. All I'm trying to say here is this is a way you can develop an application and get the operating system specific executable. Now you may ask the question, like, if it is the problem, then why do you do that? Why don't you directly create an executable that is going to be compatible with all of the operating system? It's not possible, because when we are going for an executable, the executable has got two things. Executable has got two things. One is called as the header, and one is called as the actual contents. We call it as the data. And header contains the operating system specific information. Like for example, this header is going to be different for Mac, different for Windows, and different for, let's say, Linux. Now, who decides it? Like, who decides that header, and how is it operating system specific? It is operating system specific because the executable has got a different type of executables. I'm not saying the different extension, but different type of executables. Like for example, on Windows, which is very popular operating system out there, this is called as a PE/COF. PE/COF. P/COF, it stands for Portable Executable Common Object File Format. This is called as a file format of an executable. This is for Windows. So Windows uses PE/COF. That's called as Portable Executable Common Object File Format. On Linux, it is completely different. On Linux, it is called as ELF, executable and linkable format. And on Mac, this is totally different. It is called as Macho, not Macho. This Macho is different. This is called as a Macho. Mac has two kernels, one from FreeBSD and one from XNU. XNU kernel is called as a Mach. So Macho, it means it is an executable which is compatible with the XNU kernel inside that Mac. So as you can see, every operating system has got a different executable file format. One file format is not compatible with another, and that's the reason why it is known as a native development. What's the benefit of it? Benefit is very simple. This format is known to the operating system, and that's why it gives you the best performance. So if you are looking for something like a best performance, like gaming, for example, you have to download the operating system specific game type or game format. You will get the best performance there. So if you are looking for best performance, you have to go for native development. But of course, when there are some pros, there are some cons as well. If you are looking for the best performance, you have to download it for different operating systems differently. That's Windows, Linux, and Mac. Can we not do something that will just write the code only once and it will be executed on all the operating systems? Yes, this is where we come under something called as a web development. Sorry, what the heck? This is called as a web development. So under this web development, we do not use compiler, because you see that when you're using compiler, the compiler is going to create an assembly language. That assembly language goes through something called a linking, and the linker will create an executable which is OS dependent. So what's the solution? The solution is very simple. Instead of using compiler, we use something called as an interpreter. This is known as an interpreter. Interpreter means it is a program which will understand the structure of your code, understand what that you are willing to execute here, and directly start passing those instructions to the operating system, or maybe you can say the one who is going to execute it. So interpreter will kind of, I can say, pass that to the operating system here. So in a sense, you go from this path or you go for this path, you have to ultimately pass that to the operating system, and operating system does that job for you. So for example, I can go for HTML or CSS or JavaScript, or there are many others now. Now I don't say the web development here because now I'm going to cross the limit of web, and probably I can call this as something like a interpreted development or interpreted applications development. Interpreted application development. In this interpreted application development, one of the categories is web development. Now, this is the HTML, CSS, and JS. Not only this, there is another one, Python. Could be Java, you can understand that. Could be C#, so on and so forth. As you can notice here, the code that you are writing in Python or in Java or in C#, all of them go through something called as interpreter. Now, I'm saying a star right now here. There is a reason, and I'll show you why it is called as, why I'm putting up star out there. There is some difference. We'll see that, But as you can see, there are different type of languages out there who can follow different path. There are few languages who follow the compilation path. There are few languages who follow the interpretation path. What's an advantage of compiler? The compiler, when it goes through this path, creates an executable which is OS dependent but gives you the best performance, but has its own problem. It's operating system dependent. This problem is solved by interpreted application development by following an interpreter which does not create an OS dependent executable, but instead directly executes your code and gives you the benefit of platform independent. So platform independent code or platform independence is what, if you want to achieve, you should go for interpreted code. That means when you are going for Python, you can write the code only once and you can execute it on Windows, Linux, and Mac at the same time. You don't have to worry about compiling it anywhere because the interpreter does this job. I hope you understand what's going on right now. I kind of telling you what's an evolution of languages out there and why there are a bunch of languages that you can choose from. So in this particular case, either you can travel this path or you can travel this path. Ultimately, everything has to go through operating system. Either you make an executable directly operating system understandable, or you pass the instruction by instruction to the operating system interpreter level. Whatever it is, this is how you have to get the job done. Okay, so hopefully you are all in sync and you are getting the point here. Yes, this is what I'm saying here, Hemant. This is where the Java shines, or even Python shines, or even C# shines. C# I'm putting a star mark because right now it's available only for Windows, and now it is not whole, but few of the things are available on Linux and Mac as well. I'm not .NET guy, but I can't tell you that more. But Java and Python, yes, this can, both of them can be written once, but can be executed on any operating system out there. Okay, that's how it does the job. Yeah, yes. Doesn't Java also has a compiler? That's why I put the star mark here, Abhishek. I'm going to explain that in a minute. There are different kind of, you can say, the languages out there. They not only have an interpreter, they also have a compiler as well. But first, they go through the compiler and then they go to the interpreter. That's the reason I'm kind of putting a star here. So that star is not purely interpreted. This star means it's compiled plus interpreted. In more on that in a minute or two. Okay. Fine. I think you understood that, like what exactly the languages are kind of evolved from. So there is a machine level language, there's an assembly language. You can understand like what it is now and how the assembly language have come from. Now there are different type of languages. General purpose languages can be used for developing multiple domains. Python is one of the best examples. Markup language like XML, HTML, SGML, YAML, YAML it is known as. There are different markup languages out there. Style sheet language, something like a CSS, which is used for decorating your web pages, you might have heard about. Configuration languages like JSON, XML, YAML. Query languages like SQL, specific to databases. Scripting languages like Python is a scripting language. Even the JavaScript, TypeScript, Ruby, maybe something like a Swift, so on and so forth. So all you can see, there are different type of computer languages out there, and depending on your use cases, you can choose that later. Now, there are different languages which fit in the category of high level and the low level. I mean, I already have explained all of them. You can read that later. I've created these notes for you. You can read them later. I'm not going to read every single thing for you. Okay. We just have seen what compiled languages means. Already have mentioned all of these things. Interpreted language, already have mentioned all of these things. Okay. Compiler versus interpreter, read that later. This is for you. Now I'm going to start talking about the Python and see like what exactly the Python is, in which category it fits, and why it fits in that category, and how does it really work. This is very important for you. Again, irrespective whether you want to join this course or not, understand this clearly so that once you go to that domain and when you start writing the real world program, you can understand what's really happening behind the scene. Okay, this is how Python application runs. First, understand what is a Python language. So Python is a programming language, of course I mentioned that, which is a high level and general purpose programming language. It's called as a high level because we don't have to worry about the assemblies and other stuff there. It is going to be sitting right at this particular place. If you can look at that, it fits right here, this place, which is going to get compiled and interpreted later, and then we'll go to the operating system, and then we'll go to the CPU here. So I don't have to worry about dealing with the CPUs, dealing with the assembly language directly, and that's why it is known as high level programming language. This high level comes with an advantage, you know. This is generally called as write once and run anywhere. This is like write once and
run anywhere. So irrespective of your operating system, you can run a Python application without any problems or without having any issues. You know, that's the advantage of using Python here. It's a high level language. Okay, not all high level languages are going to be having that functionality or having that feature, but Python has it. It is created by a very well-known developer known as Guido van Rossum. It was first released in 1991 before Java. Java came in 1995. Python came in 1991. So you can see it was there before Java. Okay, yeah, when you go for readability, it's known for its simple and very clean syntax, emphasizing on code readability because it does not use curly bracket. It uses a tab or indentation. I'll call it as an indentation. Indentation. I mean, this is something that I've seen in the industry also. Many a times people do not follow the indentation and their code though work. I mean, their code though give the right output, but it's not readable. That is a problem Guido Rossum solved. Guido Rossum said, I want to write the language in which developer cannot skip the indentation. And it's very true. When you are in Python, indentation is very important. If you do not use indentation properly, your code does not work. Don't you see like how awesome it is? I mean, it's forcing you to write the good code. And this is my personal experience. I started with Python way back in 2003, 2004. And I know when I say Python is your first language that you are going to start your computer career with, you have no way you can write a bad code. This is what it happens with me. In fact, even if I use couple of states, couple of spaces in between, or sometimes I use extra tab, I go back, delete it, and make it right. This is because it's in my blood now. This is because I started my career with Python. I'm telling you again, if you start your career with Python, you cannot write a bad code. You cannot write a bad code. It's in your blood that indentation is mandatory. Irrespective of language that you will write the code in, you always will follow indentation, because Python not only teaches a language fundamentals, it also teaches the how to write the readable code. It gives you the discipline. That's why I love Python personally. Discipline is very important here in the life. Anyways, this is an interpreted in nature. So Python is an interpreted language, meaning the code executes line by line, but I'll put a star mark right now. It's not only interpreted. Why? It is both compiled and interpreted. More on that in a few minutes. Right now, just focus on that. It's an interpreted, yes. But before it goes for interpretation, there is a compilation. How? We'll see that in a minute. Okay, important one, it supports multiple paradigms, means multiple programming styles, which kind of procedural, object-oriented, functional. I did not include one more here. I should have. This is called as an aspect-oriented programming, which is a very advanced stuff and which is mainly used for developing other languages. Using Python, you can develop other languages as well by using aspect-oriented programming. I mean, it's a very complex one to understand also, but it's very awesome. If you understand that, you can use it for developing other languages as well. So that's multi-paradigms language. You can go for any one of them depending on your requirement. It is cross-platform, as I mentioned just now. Once you write it, doesn't matter which language, doesn't matter which operating system that you are using, it will run on all of them. So it runs on various operating systems like Windows, Mac, and Linux. If you are, not only that, today it can also run over the internet as well. Means you do not even have to have a machine with you, or you do not have to even install Python on your machine. You can directly go to the browser and get it executed. Of course, there's a different strategy it uses behind the scene. The server may be using a Linux, for example, behind the scene, but more or less, this is a cross-platform. It can run over the internet inside a browser as well. Okay, another one. This is a free and open source. Not every open source is free, and not every free is open source, but it is both free and open source. It's freely available and supported by a large and active community. So Python has a community, which is called the Python community. It's the one which is going to control the development of Python. So that's open source now. It is having an extensive libraries. Libraries are nothing but the packages which I mentioned last time: NumPy, Pandas, scikit-learn, and so on and so forth. There are more than 300,000 packages available in Python, and that's why Python is considered to be the de facto standard in many other domains out there. It's like a battery. It's like a toy without a battery. If you are using Python without packages, so these libraries are considered as batteries in your toy. So if the Python is a toy, if I want that toy to work, I need to put the batteries. Those batteries are nothing but the libraries or packages out there. There are more than 300,000 packages out there. It comes with the rich standard of libraries and third-party packages for diverse application development. That's what I said. If you want to go for testing domain, Selenium is the one. If you are going for machine learning, scikit-learn, something like the PyTorch, XGBoost, something like a TensorFlow. There are a bunch of other libraries out there. If you are going for image processing, OpenCV is one of them. Pillow is another one. If you are going for visualization, there's a Matplotlib, Seaborn, then there's a Plotly. There are a hell lot of language packages out there. You can choose from. It's versatile in nature, as I mentioned. It is used in web development. Yes, using Python, you can develop the web applications. There is a framework called as Django. Django. D is silent here. It's called the Django or Django, which is used for developing the front end, and Flask, I mentioned earlier, used for backend development. So you can go for full stack Python application as well. It can be used in data science. You know that. I don't have to tell you that. Most of you are here for machine learning and data science. So yes, that is true. Automation, precisely test automation, like Selenium, Cypress, both of them. Scientific computing, SciPy, NumPy, both of them come under scientific computing. And there are so many other options available out there where you can use Python. Python is considered as a de facto standard in today's world because of its versatility. Yes, it's a dynamically typed. In a sense, the variable does not require any explicit data type declaration. In other languages, like for example, C, those who know C, for them, if you are writing a code in C, like integer num is going to be equals to 200. This is the instruction that I have to pass to a C compiler in order to get it compiled to assembly language, where we are saying the num is a variable storing the value of 200, which is of type integer. So this is called as statically typed language, or statically typed language, or statically typed a variable, or explicitly declared a variable. In Python, you just say num equals to 200 without bothering what's the data type of that num here is. This is called as dynamically typed language. And that is the reason why people love this. You don't have to worry about data types and other stuff there. You just declare the variable, Python will automatically decide what kind of data type it has to assign to it. So by looking at this, Python will say, oh, this is an integer. So num will be an integer variable. How does it do that? More on that later. Okay. Yes, so this is the one that we are talking about. Okay, so there are many different aspects of it. Few of them I mentioned here. There are many features also. We'll see that in a minute. This is a quick history of it. There's a long history, but just giving you a quick understanding of it. Python was conceived in the late 1980s. Precisely, it started in 1986-87. It started development, but the first version came out in 1991. Python 1.0. It is a Python 0.9, I believe. That was the first one that came out. It is considered as a successor to the ABC language, which itself is a successor by Settle. Settle was the first language, then came ABC. Now we can say Python. So the Guido Rossum, the person who is behind it, has got inspired from this. Its implementation began in 1989 precisely. Van Guido Rossum continued as a Python's lead developer till 2018, and after that he stepped out, and there's an entire community formed. So when he announced his permanent vacation from his responsibilities, a team of 5 developers or 5 members which was developed in 2019, and they started leading the project. And since then, it became a community-driven project. Yes, it's a community-driven project now. Someone is asking, since 1991, is it forcing indentation? Yes, that was a problem Guido Rossum wanted to solve. He saw many developers were not following indentation, and because of that, the code was not being readable. And that's why he said, when I develop my language, I'll force my developers to write a good quality code. He did that. And that's very awesome. As I said, if this is your first language, I'm telling you, there is no way you can write a bad code in any of the languages, irrespective of the language that you are going to use. Anyways, there are many key features. It's easy to learn, easy to use. It's an interpreted language, as I mentioned last time. So there is no need of dependent on any operating system. It's a cross-platform compatibility. It's dynamically typed, as I mentioned earlier. It has extensive library support, more than 300,000 packages out there. It supports multiple programming paradigms, as I mentioned last time. Open source and free. Again, I mentioned that also. It has large ecosystem of the libraries. It is a high-level language, so you don't have to worry about the assembly part of it. Automatic memory management. This is known as the garbage collection. So garbage collection means you don't have to worry about deleting the memory on your own. Just declare the variable, create a memory, and forget it. Python will take care of it automatically. That's called as an automatic memory management or garbage collection. It has community support. So if you are stuck somewhere, you can ask the question to the community, and community will definitely answer you back. It is scalable and versatile. Doesn't matter how big data you are using, Python can handle it very well. Python, very important. Let me share a small example just to give you that scalability and versatility. Couple of years before, I was working on a project which was having almost like few GB of the data, and the assignment came to me, handling that data, processing that data, and kind of storing the data in some other locations. Of course, after processing the data. First, I started using JavaScript because JavaScript is something that I use every day, and I wanted to use it because I know the packages out there, very well. So probably what I started with was a simple Node application, and I started working on that. It started working well. First few MBs, like few hundred MBs for some time, But after it crosses something like 1 GB, 2 GB, it started crashing. Then I realized, why is what crashing? Then I realized that this was crashing because of the language details, or the language requirement of a memory. Like Node.js requires more memory. Then I switched to the Python, and believe me, Python works so smoothly, didn't face any problem. This is my personal experience. It is very scalable. It's versatile, and it can support any amount of data. Don't you think that? Why is it the one which is considered for data science as a first language? So it means, sorry for that. It means the data is in GBs or TBs, does not matter. Python can handle it very well. So it's very scalable. It can handle any amount of data out there. And of course, it has got integration capabilities that it can integrate with other languages like C, C++, Java, so on and so forth. Okay. So again, think about this twice before you go for selecting the language when you are developing your application out there. Hemant, but Python is not that fast, and what is believed, Java is very fast. So Java is performed for the web development. Why so? No, Python is faster than Java. Compare it, I mean, head to head, and you will see Python is faster than Java. Java has got more memory requirement, more memory footprint than Python. So Python can be executed faster than Java. Check this out. Sanjana, can we cover the threads concept? If possible, definitely. This is called as an asynchronous, or it's called as the thread programming. So yes, I didn't include that here, but definitely I think I did not include it here because it comes under this particular category. Thanks for letting me know. That's the threads. So yes, ma'am, we are going to cover that there. Don't worry. Asynchronous programming, it is known as. So we will be covering that as well. Okay. Java cannot process millions of records efficiently like Python does elegantly. Yes, Abhishek, that's very true. And that's the reason why we are choosing Python in data science more than using Java. Okay. Fine. Okay. So difference between C and Python, you can read yourself. That's not something I don't want to waste my time here. Versions, not so important. I think better for us to see how a program looks like. I mean, I'm going to stop talking about the theoretical part now, and I'll show you a very small example of it, so you can understand like how it is possible for us to start developing the applications. Don't worry, I'll talk about how do we get it set up later. I'll send you some instructions also, but more or less you just have to download that, something like this. Sorry, let me just go back here. You can head towards Python. Sorry, you can go for python.org. So you just go back to the Python, go to the downloads, and then you can download it as per your operating system, like Linux, Mac, Android, Windows, so on and so forth. So basically, if you are on Windows, just click on that and download one of the packages. I would recommend do not go for 3.14, go for 3.11. I mean, if you are willing to go for data science, there are many libraries or there are many packages out there which are not compatible with 3.13 onwards or even 3.12 onwards. So it's better you go for 3.11. This will give you the compatibility if you are willing to go to data science later. Right now, if the Python is the only thing that you want to learn here, I think you can choose anyone. I mean, you can even go for the latest one as well. There is no problem. Just make sure that you are downloading the stable version and not the pre-release. Pre-release has sometimes, has a crashing behavior. So it's better you can download the stable version of it from this side, left side. Just download it. It's just an executable. Double click, next, and it will install Python on your machine. Okay. Let us say I've installed Python. Now, how do I execute it? Now, there are two ways I can execute the Python code. One of them is called as a Python interpreter. You can go for Python 3 if you're on Linux or Mac. And if you are on Windows, just say Python and it will execute, or it will give you something called as this Python console. In this code or in this console, I'll start writing my code. Now, for example, if I want to print hello world, I can simply say print hello world, something sort of that. And this will give me an output like hello world on console. That's it. Very simple, very straightforward. So in this particular case, the code that I've written, something like a print hello world, it is going to print a hello world on my console. This is where we can write the code line by line and execute it line by line and get the output line by line. But if I do not want to go for line by line, so probably I can write a code in one of the files. Like for example, what I'm going to do right now, I'm going to go for creating a new directory for us. This is going to be Python. And within that, I'll create a directory called as a day one. I'll share day one. So I'll share everything with you later in one of the Git repositories out there. There is a code, and whatever I've written, I'll put that inside the nodes directory. Okay. So what I'm going to do right now, let's go back to this code directory here. And I'm going to use the Visual Studio Code here. Visual Studio Code, you probably have heard about it. If you haven't, this is a very good editor. This is the only product from Microsoft I like, other than Office. So this is something which you can download here easily from internet by saying Visual Studio Code, not Visual Studio. Visual Studio Code is what we are looking for. So you can go for open source. I don't want to use AI part of it here, but at least it's an open source editor. You can download it and you can start developing the applications there. So first thing, when you download Visual Studio Code, go to the extension tab. This is an extension tab and search for Python. So this will install the Python linter and Python libraries so that it will start giving you the IntelliSense here. So if you go to the Python and say install, this is the Python from Microsoft, just download it. So it will start giving you the Python Python IntelliSense. It's like you are going to use the Python, the Python entire IDE for you. So just install that Python extension and start writing the Python code. Very simple. So I'm going to create a new file here. I'll call this as program1.py. Extension of Python is going to be py. So in this case, we'll start writing the code. Now, the code that I wrote there, I'm just going to copy and paste it here by saying print hello world. Simple as that. Now, earlier I was executing that code line by line, but this one I can write bunch of lines of code together in a file with an extension .py, and then I can execute it by using the command something like Python3 the program1.py. So if you're on console, just use the Python3, use the name of the file program1.py, execute it, and you will see the output of that code. So here the advantage is you can write multiple lines of code together and it will print output of every single line when you are going to execute it. You know, this is a very simple way you can write the code and you can execute it. Now let me show you, or let me tell you what has happened when I execute this code here and what exactly the use case here, or what exactly Python does here in order to get it executed. Okay, so let us see. Just give me a second. Okay, let us see how does it work. Okay, so when you are going here in this particular code that I have written here, I am going to, you know, simply tell you what exactly happens here. Now, please pay attention. This is the one, this will help you to understand how Python code gets executed. There are versions and other stuff. Environment, I think you can download this and you can install this. Now, what we have downloaded is called as the C Python. We'll talk about that in a minute. But before we talk about this, I will talk about, this is what I want to talk about here. So when you download that, something like the Python from your python.org, what you download is something called the C Python. I'll talk about that in a minute. But before I talk about the C Python, I want you to understand this entire philosophy of how the Python code gets executed. So this is what happens here. You as a developer will write the Python code, something like this, you know. So I wrote a file. This is the file. And in this file, I wrote some Python code. So I can call this as a program1.py. You know, I write some code here. This is the Python code that we have written here. And this Python code is what I want to execute. Now let us see what all steps the Python goes through in order to get it executed. Okay, so let us see what it is. Okay, let's see. So when you are going for program1.py, I want to execute it. Did you notice it? How did I execute that on console? I use the command called as Python3 or Python, and then I pass the program1.py. That means I passed my file to Python3 as a program, which means if I go through it, this is what I'm passing here. It is Python3. If you're on Windows or Mac, if you're on Linux or Mac, you are going to use the command Python3. If you're on Windows, you can just use Python. That's it. So Python and Python3, both of them are same. So it depends again on which operating system you are using them. So when you use this Python3, what happens here? Whatever code that you have written in Python, all these instructions will get converted into something called as bytecodes. Maybe I can say bytecode 1, bytecode 2, so on and so forth. So ultimately, when we are going for Python code, and if we are passing it to Python3, Python3 compiles this code. So this is where the compilation happens, you know. So it compiles this code into something like the bytecode instructions. So these are the bytecodes, you know. So these bytecodes are nothing but the compiled version of your Python code. So this is my bytecode 1, this is my bytecode 2, this is my bytecode 3, and so on and so forth. This file, which is hidden, you can't see that right now, but this file is hidden, which is known as something like a program1.pyc. So python.py file here gets converted into pyc file here. Pyc stands for Python compiled. So what happens here is your Python code gets compiled into something called as bytecodes. Have you noticed it? This is something which we have talked about earlier in case of assembly language, So if you are going for that compiled version, you saw that your C language got converted into the assembly language. So this is what I'm talking about. C language got converted into assembly language, and later using linker, we got it inside the executable. But now that is not the case. We are having that assembly language. But this time, the assembly language that I'm using here, it's not the assembly language for the real CPU. This is the bytecode, So when you say the bytecodes, let me mention that here. The bytecode, the one that I'm showing you here in that box, that bytecode or bytecodes are the assembly instructions. ASM means assembly instructions, or you can say assembly code, assembly instructions for the something called as virtual CPU in something called as PVM. This is called as Python virtual machine. Let us see what happens here now. So when you are going for compilation or when you are going to execute this code, this is what it does. First, it passes this to the Python 3, and Python 3 compiles it down to something called the bytecodes. What bytecodes are? Bytecodes are the instructions for virtual CPU in PVM. What it means here is it gets compiled into PVC, which internally again passes through, or it calls the same executable again, something like a Python 3 or Python if you are on Windows, and then it starts interpretation. So it interprets this by loading it inside that PVM. This is the PVM. This is called as Python virtual machine. Python virtual machine. So when I say Python virtual machine, in short, we call it as PVM. This is the same concept that you can see in Java as well. Literally speaking, in Java, the bytecodes are also called as the bytecodes. The PVM becomes JVM, but the concept remains same. Here you are having Java file. Here you are having class file, which is having a bytecodes, and there you are going to run it inside the JVM. So of course, this is similar to Java. Okay, concept is similar, philosophy is similar. So within this Python virtual machine, we are going to load our pyc file, .pyc file, and then it starts getting executed one by one. So basically, when I say this is a Python virtual machine, this is the machine, but it's not physical, it is a virtual. That's the reason why it has got a virtual CPU inside it. So this is called as a vCPU. vCPU means it's a virtual CPU. It's not something that you can see. It is there inside the code behind the scene. That's why it is known as a vCPU. If you read what I said here, these are the bytecodes which are instructions, assembly instructions for this virtual CPU. This virtual CPU is in Python virtual machine. Not that you can see anywhere, but this is the Python virtual machine. Now what it does, this particular Python virtual machine simply converts this into the real assembly instruction, and then it passes that to the CPU. So precisely, I think I can show us small here. This is my CPU, machine's CPU, physical CPU that you are having, and then it going to convert it. Interpret means it converts it assembly for your CPU. The CPU can understand assembly instructions, not the bytecode. This is the CPU instructions, and this is the job of PVM. PVM reads all the bytecodes and get them converted into assembly, pass them to the CPU, and the CPU executes the file. Our CPU executes the instructions and gives you output back to the user. So this is what it does behind the scene. So whenever you are in the Python, you are writing code in Python, when you pass that to the Python 3, understand what happens behind the scene. It passes that to the code gets passed to the Python 3, which is the compiler. It compiles down to the bytecode. The bytecode gets loaded inside the PVM, and PVM passes these instructions by converting them to the CPU understandable assembly. So there are two assemblies here. One assembly here is called as PVM, bytecode, which is the assembly for virtual CPU inside the PVM, and another one is the assembly for your real CPU, and this is the job of Python virtual machine. So PVM is the one which is going to execute your code. Now, when you are going to download this, when you are going to download your Python from your machine, or sorry, Python from your Python website, this is what we are going to download, which is called the C Python. And the C Python also includes something called as PVM as well. You do not have to install PVM explicitly, separately. This PVM is operating system specific. This is OS dependent. Have you not seen that? When you are downloading Python, you need to first choose which operating system that you are on, because the PVM is by also OS specific, operating system specific. So PVM for Linux is different, PVM for Mac is different, PVM for Windows is different. The good thing here is I don't have to worry about it because I never use it explicitly. I use Python code, which I'm going to pass it to Python 3, and it's a Python 3's headache to load that PVM and get it executed. So I don't have to worry about that. This is OS dependent. This becomes OS independent. This is OS and CPU architecture independent. This is the beauty of using Python, and of course using Java as well. But this is what you can see here. This is the Python, which is like CPU architecture and OS independent. It gets converted into bytecodes. That is going to get converted, loaded into vCPU or virtual Python virtual machine, which is OS dependent, and then it will get executed by using the CPU. This is the reason why we have to install Python, which is operating system specific. I hope you are getting all the steps that is going to be followed. I mean, all the steps that we are following here to execute our code. Okay. So you can use any of the IDEs, PyCharm like IDEs, for example, or editors here. So maybe I can go for an IDE here if you want. I generally do not recommend that because they are bulky, they require more memory, and it is not required, to be honest. So if you want to do it, it's no problem. You can. There's something called the PyCharm. I forgot the name. One second. It used to be the one of the options we were using, something called as a Spider, I believe. Spider Python ID. Spider, it is same thing. Spider ID. That also is another ID that you can use. It's a free, of course. You can use that. PyCharm and Spider. I used to use that earlier, but when I started using Visual Studio Code, I really liked it. And you can also go for simple editors. The one that I'm going to use is called as a VS Code. You can also go for something like Sublime, or you can go for something called as an Atom, or you can go for something like, there are many options. How many of them I can tell you. So you can use any one of them. You can write this Python code here, and then you can start passing it to the Python 3, which does the rest of the job for you. Okay. So editor or PyCharm does not provide PVM. The PVM is provided by the package that you are going to download from here. So when you download this, one of this, for example, that includes both the Python virtual machine, Python, you can say executable like Python 3, the one which I'm using here, and everything. So you do not have to worry about which editor that you are using or which ID that you are using. This part here will be given by the python.org package. Okay. This is what it does behind the scene. Okay, so Yogesh, what about the Mac? Mac, it's the same thing. You can download it from the Mac also. So if you go back here into the Mac version, by default, you can see the versions which are available. Just download it and get the things. Get the thing installed on your machine. Okay. Next one, with that, you are planning to use a PyCharm as it's similar to IntelliJ, which I use. No problem. IntelliJ and PyCharm, both of them are developed by the same company called the JetBrains. That's why it is similar, you can say. But I would not recommend PyCharm because it requires more memory. That's the only concern I'm having. So if you are okay with that, I have no problem. VS Code is at least 10 times faster than PyCharm. That's the reason. But again, this is your personal choice. Yes, Manisha, you can also use JetBrains PyCharm. There is no problem. Amit, is the terminal kind of running for a shell? Yes, this is the shell that we are kind of running here. It's called the Python shell or Python console. If you just use the command Python, you can say it is running something called as a Python shell or Python console, it is known as. Okay. Hemant, but in Java, we ship the .class files to jar files. Can we do that in Python? Yes, you can. Once we are done, you remember what I said under deployment? in deployment, we'll be converting to the PyC, and the PyC is what we are going to pass. We will not pass the code, Passing code means you are kind of telling like what exactly you have written and you are showing everything to the client. You don't want to, right? That's the reason. Instead of shipping the Py file, you can definitely ship PyC file as well. Definitely, yes. And this is what we are going to see inside the deployment part towards the end of it. Yeah. Kulvinder, is PVM also installed with the or with the Python? Yes. When you download Python from Python.org and if you install it on your machine, this is what it also brings along with it. PVM as well. Okay. Yes, Sanjana, that's why we have to install Python based on OS. Yes, it provides a PVM. Yes, that's right. Hemant, is there any jar-like structure? Yes, that PYC file is a jar-like structure. I mean, PYC itself is like a jar-like structure, And I'll talk about other options available out there. There is a native version also, but we'll talk about that towards the end of it in the deployment. Yes, Amit, sys version, blah, blah, blah. It's all right. There is no problem, Amit. You can go for 3.14 as well. There is no problem. It does not matter whether you are using 3.14, 3.11, 3.12, because the language that we are learning has got almost similar stuff from the coding perspective. Okay. Fine. I think you have understood like what happens when you are developing a Python application and how the Python application runs, right? This is what you can do. Now, let us first answer this question. What exactly have you downloaded and what exactly the version that we are going to use? Now, please pay attention here because this is going to tell you what Python version is not 3.1 or 3.12, what type of Python you are using on your machine. So when you are downloading from that website, python.org, what you are going to download, let's see here. Python has got many versions like CPython, PyPy, Jython, IronPython, and so on and so forth. What does it mean here? If you can understand, this Python 3 as a compiler or this PVM here, the one which is going to load and run your code, both of them are written in C language if you are using CPython. They themselves are written in Python if you are using PyPy. They are written in Java if you want to go for Jython. They are written in Iron language if you are going for IronPython. So basically, in which language the Python and the PVM is written, that is the one that you are kind of deciding before you download anything. The default one that you are downloading from python.org is called as a CPython. So the standard version is called as a CPython, which also is most of us get when we download it from the official site python.org. Henceforth, when we say Python, we are talking about the CPython. Now, what is the CPython? Let's understand that. This is one of the interview questions people generally ask in interviews, like what is the CPython and Python? Let's see. A CPython is a reference implementation of a Python programming language. What it means here is Python is a standard programming language. So if you go back and say this is the language means it's a coding. So how you want to convert that language or how you want to run that language, you can run it by using variety of ways. You can go for CPython. You can run this by using PyPy, or you can run this by using Jython. There are many options available there. The default one is something like CPython. I mean, there are options available out there. So this is the reference implementation of Python language. So Python as a standard language is implemented by many different vendors. CPython is one of them. Okay, what does it do? It is written in C and it is written in C and as a standard interpreter for executing your Python code. When I say interpreter, I'm talking about this interpreter. I'm talking about this as a compiler and interpreter here. So this one and this one is written in C if you are using CPython, and that is the default case available here. So CPython is an essential component of a broader Python ecosystem, and it provides the core functionality that developers interact with when they are working with the Python. So when you are working with the Python and when you are done with the coding, if you are going to execute it, this is going to be done by using CPython, right? What are the features of it? Wonderful. That's a reference implementation, means a standard implementation of a Python. So if you are to develop a Python and if you want to run it, this is the one that is considered as a default one. It's called as CPython. It is written in C. You will get the best performance out there. And that's the reason why we are insisting that you always go for C Python here. And that's a default one. You don't have to worry about that. It's a C Python, it's a default one. It's an interpreted language, which means when you are going to be using C here or C here, for example, still it has to follow all the different steps that I mentioned earlier. It is still an interpreted language. And it provides a C API. That means the Python code can be executed from C, and Python can also call a C code as well. This is what we said earlier in features of Python. If you could recall, I said this is integration capability, means it can integrate with other languages like C, C++, and Java, because the C Python is what we are using right now, has got the C APIs available there. And that is the reason it can be used. It can be, calling the C code, or C code can call the Python code as well. So that is integration possible by using the C API. And that's the reason why it is considered as a reference implementation of it. Okay. Now, when you're going for C Python, as I mentioned here, the code that you are going to write will get converted into bytecode, and that will get executed inside PVM. So there is a bytecode compilation. In this case, the bytecode gets generated first. So when a Python script executes, Python first compiles the source code into something called as a bytecode. So as I mentioned, the bytecode is nothing but the assembly code for virtual CPU inside your PVM. Bytecode is a lower level platform independent representation of a source code. Have you not seen that? This is going to be platform independent. That means that it has to be executed by using something called a PVM, which itself is a operating system dependent or platform dependent. So bytecodes are platform independent, but PVM is a platform dependent. Remember this point. Execution by virtual machine. So that bytecode that we have generated here, which will not be executed by your real CPU. Who will execute them? It's a PVM. So C Python's virtual machine, called the PVM, Python virtual machine, executes the bytecode, as I was saying earlier. And this abstraction allows the portability, flexibility, as the bytecode can run on any operating system that supports Python. Good thing is that C Python is supported on Windows, Mac, and Linux. So you don't have to worry about that. That's what I said. When you are writing Python code here, this becomes architecture, CPU, platform, whatever you can say, independent. So you don't have to worry about the platform that you want to run this code on. It will be executed everywhere or anywhere for that sake, because the PVM that you are using here is platform independent. Yes, it's a standard library and built-in modules. So it is considered as a standard implementation. Those modules which I mentioned earlier, hundreds and thousands and 300,000 modules out there or packages out there, all of them are written considering the C Python in the mind. And that's the reason you have variety of packages to deal with. So extensive standard libraries. Yes, C Python comes with comprehensive standard libraries that provides access to wide range of functionality, including file IO, system calls, internet protocol, and so on and so forth. There are many options available out there. Of course, there are built-in modules as well. The C Python includes a collection of built-in modules written in C, which enhance the language's capabilities and performance as well. One of them, or few of them I mentioned, like OS, RE, CVS, threads, all of them are built-in modules. But not only built-in, there are many other external modules available that you can download and you can start using them in variety of ways. So in short, this is called as the standard or reference implementation. This reference implementation is going to give you the best performance, and that is the reason by default when you go here and when you download this version, it brings something like the Python's C Python implementation. Yes. Yep, that's the way it is. That's the way it is going to be the case. Okay. Fine. I think this is what I mentioned last time, how the Python hello world code kind of executed. C Python is not compiled language. It's a misconception. It's both compiled as well as interpreted. Never say it's only interpreted. It always is compiled and interpreted. Okay. When you are studying for interview, mention this. It's not only interpreted, it's both compiled and interpreted. And draw this picture. So it will be crystal clear for the interviewer also, like what exactly you are saying is what exactly you know. You are not just by-hearted it, but you know how it works. So first thing, C Python has a compiler base, as I mentioned. The Python code gets compiled into bytecodes. The CPU cannot understand the bytecode because it's not meant for it. It is meant for vCPU inside the PVM. So we need an interpreter to understand and execute these bytecodes. This interpreter is nothing but the Python virtual machine. So the Python virtual machine interprets this code by converting it into the CPU assembly which will get executed by the CPU itself. That's what it does. Okay, that's how it does. Fine, I think you must have understood. We'll talk about PVM maybe in great details later, but just to give you a context of it, PVM is a runtime engine for Python which executes a bytecode compiled from the Python source code. So it is the one which is going to execute your bytecodes. After Python code gets compiled into the bytecode PYC file, the PVM interprets it and executes that bytecode step by step, one by one. The PVM is the final layer of the Python interpreter, which includes the compiler, which converts the source code into the bytecode, and the PVM, which includes or which executes the bytecode. So basically, this is a package that you are downloading. You are downloading the compiler as well as interpreter. It is a platform independent, as I mentioned. So the PVM ensures the Python code can run anywhere on any platform where the Python is installed, making it as a cross-platform language, which means if you're writing the code on Windows, you can execute it without fail, without having any issues on Linux or Mac. Vice versa is also true. So you don't have to worry about compiling it for every single platform individually. You can write it on one platform and execute it on another platform easily. It's not a separate program. Absolutely. PVM is not a standalone program, but it is embedded. It is there inside the Python's interpreter. You don't have to download it separately. When you download Python, when you install Python, it by default gets installed along with it. So you don't have to worry about that. That's a PVM. And finally, when you are going for this is how it executes. The Python source code is compiled to bytecodes. The bytecode gets executed by PVM. The PVM translates the bytecodes into machine-specific instructions, means assembly language for the CPU, and CPU gets executed there. Now, from performance point of view, PVM is slower than directly executing the machine code. Of course, we know that. We already talked about this. This is a bit slower to compare with C and C++ program. I'm not comparing with Java. It's way faster than Java. But it is slower than C and C++ because C and C++ directly interacts with the CPU. In Python, we are not directly communicating with the CPU. We are communicating with the PVM, and PVM communicates with the CPU. And that's why it adds some delay. And that is the reason it is a bit slower than C and C++. Because it interprets the bytecodes at runtime, it executes the bytecodes instruction by instruction at runtime, it is going to be a bit slower. But compared to what? Compared to C and C++, not to Java. Java is slower than Python. Python is way faster than Java. However, tools like just-in-time compiler, what calls a JIT, it is known as, or PyPy, for example, can optimize the PVM performance. Not that you have to worry about it right now. We'll worry about that later. And finally, I mentioned this last time, garbage collection or automatic memory management. This is the feature of PVM. So PVM also handles memory management, including garbage collection, that free up the unused memory, making the memory managed automatically for you. So you as a developer don't have to worry about how to manage the memory on your own because Python will take care of it on its own. So you have to worry about nothing. Okay. Yes, that's how it is. Anyways, I think there is no point continuing further today because we have covered many things. Hopefully you have understood how the Python code looks like, how the Python code can be executed, what is the the way you are going to see the Python code is getting executed. We also have seen like what are the languages, compile languages, and we also have seen a quick introduction to what exactly we are going to cover. Enough, hopefully. Okay, can you set up how to virtual machine in VS Code? Yes, Abhishek, not right now. We'll talk about that later. I said that earlier. Today we'll talk about physical environment. Later on, we'll talk about V environment, or it's called the virtual environment. We first need to understand what problems that we face, and ENV is a solution of what kind of problems, So we'll see that later. Manisha, as the C Python or as the Python supports both compiler and interpreter, so it's a hybrid language like Java. Yes, Java and C Python, both of them follow the same philosophy. Not only Java, C#, Java and Python also follow the same philosophy. If you look at that example or the diagram which I mentioned earlier, sorry, what the heck? Where are you? If you look at that if you look at this diagram here, this is the one. So if you can see here, we are calling it as a bytecode. In Java also it's called the bytecode. In C# or in .NET it's called the MSIL. Microsoft Intermediate Language it is known as MSIL. Here it is PyC. In Java that's a dot class, and in case of C# that's called the net module, .NET module. When you are in Python you call it the PVM. When you are in Java you call it the JVM. When you are in C# you call it the CLR. common language runtime it is known as, So C# or .NET, Java and Python, all of them follow the same philosophy, you see. So when you are learning one, you can get other two free of course. That's how it is. Hemant, it's too long. Can we go to do Saturday, Sunday? No, that's how it is planned. We have to finish those topics here. I know, but 2.5 hours, I think it's not that big. You can definitely have more time in a day. You can revise it if you want. Okay. Yes, I think only C Python platform is independent. No, all of them are. But when you talk about the default implementation, the reference implementation, that's a C Python because it's widely available. It's kind of faster than others. That's the reason. Okay. Manish, I can't do anything at the moment. That's how it is planned earlier. Okay. Amit, we will get a soft copy. Of course, whatever that I'm writing here, whatever that I'm drawing here, I will be putting up there in your directory, the directory which I showed you, You're going to get that Git repository later, maybe today or tomorrow, I think, or maybe in the next session, and then you will start reading it on your own. Okay. Don't worry. Yep. Hemant, no problem. That's exactly why we are here for. Exactly, Emma. That's what the point here is, in fact. So we generally go for other sessions like Gen AI and other thing only for 2 hours, just because there are too much that we have to see there. Here it's very simple. That's the reason why we are having 2.5 hours. Actually, I was proposing 3 hours, but ma'am says no, 2.5 hours more than sufficient. So we have gone for only 2.5 hours. Okay. Why we are using virtual environment for Python and Java? Don't worry about that. Who's that? Nisha. Don't worry about that. We'll talk about that later. I mean, you should understand what problem that you're going to face. Unless you face the problem, there is no way you can appreciate what the solution is going to bring on the table. So better you face the problem, get frustrated with it, and then I'll tell the solution of virtual environment later. Okay. Yes, Aditi, are we going to use the PyCharm or VS Code? I'm going to use VS Code. If you want to use PyCharm, you are free to do that. No problem. Absolutely no problem. If you are comfortable with PyCharm, you should use it. I'm comfortable with VS Code, and I'm telling you, VS Code takes a lot lesser memory than PyCharm. So I don't want to waste my memory in something that is not needed. So I would use VS Code in that case. Okay, it's up to you. You choose whichever that you are comfortable with. Yeah, so if I understand that, Hemant. Can't help. Yogesh, some location for recording session too? Yes, not same location. You are going to get the recorded session in your student portal. Maybe Rahul sir will send instruction later, and then you can follow the instructions in order to get your recorded session there. Don't worry about that. Yes, no problem, Anisha. That's what I'm here for. So don't worry. If you still have got any questions, you can throw at me. Otherwise, I think today we have seen enough. No problem. So probably better we can stop here for today, and we'll continue with the next session. Okay. Important note, important instruction, important point. I think today is Friday, right? Saturday, Sunday, there's no session, of course. Monday 26. I think Monday we are having a holiday, so we will not have a session on Monday. It will be directly on Tuesday. It will be almost Saturday, Sunday, Monday, 3 days gap. Okay. So please take a look at this. I'll share this PDF on your WhatsApp group for today. Later on, it will be shared using your GitHub repository only. Okay. Because I know we haven't set up the GitHub repository yet, and I don't know how many of you are going to get confirmed. So probably once you confirm, you will get it that later. But today I'll be sharing that PDF file on your WhatsApp. Please go through it. And on Tuesday, don't be blank. Okay. At least read something there. Okay. Yes, Eamon. After many days rather. Anyways, chalo. So thank you guys for attending today's session. I hope you have learned something new, and hopefully you are going to learn the next things, the one that we have planned for you. Okay. Again, have a very good day, very good weekend, and then we'll see directly on Tuesday morning, 8 o'clock in the morning. Okay. Thank you very much. Bye-bye.
Yes, sir.
Thank you.